Warner Brown. I'm the president of Tech Labs. We've got
Guys,
a
already
lot of things happening today, so a lot of
moving
moving parts. But we're very, first of all, thankful that you're here.
Well, we're going to start in here
and
and kind of
a lot to
break
learn
out
about.
there,
A lot of our team has prepared and worked very hard to have things to showcase to you. We have a lot of our biggest partners here as well. The first presentation this morning is going to be Tony Niswander. He's the president of APT Manufacturing. There's Dallas Bergstrom. I'm calling him out. He's my buddy. How you doing, Dallas? Good to see you. Thanks for coming. And then Eli, who is our welding and automation specialist, is going to show y'all one of the APT solutions, as well as a few others that we have outside, which could play well within welding automation, industrial maintenance, electrical and electronics as well. So I'm going to turn it over to Tony. So we'll be in this room. We'll be in the warehouse, and we'll be in the conference room and one other demo area, and we'll play it by ear. I'm sure that it won't go perfectly, but we are obviously going to be available to help you and answer questions. So if you're looking to find somebody that's on our team, you just find somebody that's got a little name tag like this, or Eli's, and they'd be happy to help you. We will have breaks where you could ask specific questions, spend time with Eli or our friends if you want to see something specifically or get into more detail about a solution. So Tony, over to you. Thank you very much for being here. Appreciate it.
Invite. Appreciate
yes, sir.
it.
I'm going to scoot in front of you and then I'll sneak around.
So I'm Tony Niswander, founder of APT Manufacture. A little bit about our company, and what I should say this. I want to talk a little bit about our products this morning, and I'm not going to get in depth with a lot of products. We're going to specifically be talking about welding in this event.
Yes.
In a couple hours, we're going to be talking about our ILS, which is another product. But our company is in Northwest Ohio. I'm a very large FANUC integrator. So FANUC is the #1 robot company in the United States or in the world. And I'm an exclusive to FANUC. So last year I was awarded in the top 1%. We're in the top 10 out of 1,000 integrators. We do a lot of FANUC. A lot of people say, why are you FANUC? I've never lost a job because of FANUC, and I have 100% support no matter where my equipment goes anywhere in North America. So actually anywhere in the world, they got support, but I don't ship all over the world. I'm really in the Americas. So this is my building. It's missing about 25,000 square feet on this picture, but we've got about 100,000 square feet, 100 employees. I'm in manufacturing, so some of you guys are manufacturing, some of you guys are education. Why am I standing in front of education? How did I get there? So I started the company in '96, my wife and I did, and we've grown. We started in a garage, and we've grown to this point. I started out at a vocational school for auto body. I learned to weld, got certified as a welder. I got married really young, went to a fab shop, and I was a welder for about 3 years. Hired in at a tool and die shop and become a tool maker, went through an apprenticeship program. So what I know is vocational schools and apprenticeship programs. That's my background. We grew the company and we bought this building, which was the dark roofs here. We bought this building in 2012. And I had 50 employees. And in 3 years, we went from 50 to 120 employees. And at that time, I reached out to education, my vocational school, my community college, and I said, I need help. I need kids with a teach pen in their hand. There was no cobots at the time. I need a teach pen in their hand, and I need tool makers. And I went to my vocational school, my community college, and I took them to FANUC America, which is in Rochester Hills or Detroit, and I showed them FANUC as well. And they never started anything in the machine shop as a tool maker, and they never bought a robot. So I started my own high school training program in 2013, and we brought in 5 students every day, 5 juniors, 5 seniors, 10 students every day, from 1 o'clock to 3 o'clock every day in our plant the whole year. Then the juniors, they went through everything, and the juniors, when they become seniors, what did you like? Did you like electrical or mechanical? And so what that taught me was a lot about education. Paul Aiello, the director of education for FANUC Americas, came to me and said, Tony, will you build me a advanced piece of equipment? So if you understand education in FANUC, they had what's called a CERT cart. This is a CERT cart, a robot on a cart. with a PBL. I never knew what a PBL was until I got into education, a project-based learning. FANUC had this. But what education was asking is, can we have a system? So we built this from Macomb Community College in 2014, and this added Rockwell. It added a conveyor. It added a area scan or a light curtain. It added safety. Now we had a system. And I went back to Paul and I said, Paul, is there any way that I could sell this to schools all over the United States? And he said, yes, but no. I'm like, what do you mean no? And he said, well, let me introduce you to Tech Labs. Let me introduce you to the ESPs, the education solution providers, all over the United States. So he introduced me and we launched this product. And in launching this product, I got feedback from you guys, the schools, that said, hey, we want it. We want it. And I told my wife, I said, hey, we're doing good. We've got purchase orders coming in. And nothing happened. And nothing happened. And nothing happened. And I called the Tech Labs of the world back and I said, I thought the school was interested. And they said, oh yeah, they put it in a grant. It'll be a year from now. Okay? So I never understood your world until then. So today we offer a lot of products, but I wanted to just let you know that we do the integrated products. So I'm either integrated with Rockwell, integrated with Fronius, integrated in the welding, integrated in the industrial. We are integrated products. We also have curriculum writers today. We write curriculum. We work with FANUC's curriculum. We work with Rockwell's curriculum as well. So this 20 minutes that we're engaged, you guys can stop me at any point. We can ask questions. Just to look at this, I have CNC equipment that we integrate the robot to the CNC, the FANUC RoboDrill. Mechatronics equipment, which is where I just was, and you're going to see more of this today at 12:30. We're going to talk about the ILS. But this portion of it, we're really going to talk about welding. It is amazing to me what's happened in the last 4 years, okay? So in the last 4 years, in February of 2020, FANUC launched their cobot. This is the white robot. Now, FANUC always had the yellow robot, which we're going to call it the legacy robot, or they're all industrial. So I used to say this is industrial and this is a cobot. No, they're actually all industrial, okay? So to talk a little bit about that, what the difference is, and to talk a little bit about FANUC first, I should say, FANUC was started in the 60s as a servo motor company. Then they started software to control the servos, and they launched the CNCs. And anybody that's older, you're going to talk about an old tape machine. We used to feed a tape into a CNC, okay? FANUC wasn't a robot company. FANUC is a CNC company or a servo motor company that controls the servo motors. In the early 80s, General Motors went to FANUC and said, hey, is there any way we could build a robot to paint? It was called GMF, General Motors FANUC, from the early 80s to the early 90s. In the 90s, FANUC went back to General Motors and said, we want to break off and just be able to build robots for everybody. But the robot industry started out really in the high production areas, General Motors areas. And so when we're talking about welding, and we would sell welding, we would really look at a yellow robot, a high volume, low mix. I'm going to set this up for an operator. I got to have a PLC, an HMI to be able to control it because an operator is going to run this, not a controls person. And so that's what the robots were up until February of 2020. And this big buzzword of a cobot. A cobot is a slang word for a collaborative robot. So it's still a robot. FANUC's robots, most all of them, have 6 axes. Really what that means is we have 6 servo motors. And FANUC is a huge software company and they control the servo motors. FANUC's white cobot in the welding world does not need to have a jacket on it. A lot of cobots need a jacket on them because of the sparks and the arcs. FANUC said, no, we have an industrial cobot, okay? What makes that a cobot versus a robot is there's sensors in all 6 axes. So when I'm around it, if it hits me, touches me, it stops. I always say it's like having a 16-year-old in production. Hey, if I just teach you this, will you just do this for the next hour?
100%.
And then I'm gonna walk away and I'm gonna grind or I'm gonna set up or I'm gonna do something. And when you're done, will you just stand there? That's the difference between the cobot and the 16-year-old. 16-year-old disappeared, right? But it sits there and it waits on the next instruction. And it's so easy to program. And Eli's gonna show that on the ModWeld, our product out here. So we launched what we call the ModWeld products. And I have to say to industry and education, I build industrial equipment for the industrial and the education market. I don't dumb anything down. So you are getting an industrial piece of equipment, whether it's welding or material handling, you're getting an industrial piece of equipment in your lab. All right, I need to say that because they're all built identical. What's different in this cobot, okay, versus, now I'll say that in a minute, versus this cobot? Well, the only difference is this is a 10L, a long arm. This is a
10.
Oh, that's a 5. Okay.
Well, yeah.
So anyways, we use a 10 and a 10L. Fanuc has a 10 and a long arm. The difference between a long arm and the standard is this arm right here is bigger and the robot can swing under itself. So the only thing I do different education to industry is industry gets the L because they need the longer reach. Education doesn't need the longer reach, so they save $3,000 or $4,000 and we ship them with the 10. Other than that, they're both industrial cobots, okay? When we designed the weld system, we designed it for our own plant. So I have about 15,000 feet that's dedicated to welding and fab and powder coating and sheet metal laser, and we make everything in-house. We powder coat everything in-house. And so a lot of companies put a robot or a cobot on a cart and they put a power supply under it and they call it a system. Okay, that's good. But a system really truly is, I wanted to take advantage of the robot, not of the power supply. Power supply is very important in welding, but if I can get a 55-inch reach, why would I not want 110 inches across it? And that's important for education as well, because what I want, when we design a system in education, I want your students to see industrial equipment in their education lab, so when they go into industry and they interview, it's not a deer in the headlights. So all of our equipment is built to the standards of industry, feel, look, and parts. Okay, so it's frustrating because I wear both hats. It's frustrating on the industrial side when I interview a student and that student comes in and he's like, I've never seen equipment like this before. And he's nervous in his interview versus a student walking in and saying, hey, can I hand you a teach pendant? Yeah, here, I'll move the robot. Can I give you a laptop with Rockwell on it? Yeah, no problem. Let me do some things here. But the feel, the cages, everything that we do feels the same in education and industry. So that's why we can add 4 side carts to this. So the 4 side carts allow me to be 55 inches. We offer 2 power supplies. It says choose your power supply. We offer a Miller and a Fronius. I'm going to talk a little bit about both of them. In the United States, we see a lot of Miller, Lincoln. We see a lot of that. And so I partnered with Miller in 2019. And in 2022, I partnered with Fronius as well. So you have a choice. What should you choose? Well, I say first off, you should choose what's in your area. If you're in education, you should choose what's in your area. However, I'll also say that Fronius looks at it totally different than what Lincoln and Miller does. So in the welding world, we think of Miller and Lincoln because they're a really old company. And maybe this is the first time you've ever heard of Fronius. And you think, well, Fronius is a new company. Actually, Fronius is a really old company as well in Austria. So what are they doing in the United States? Well, in the early 20s, so 25 years ago, they came to the United States with the automotive companies from Europe. Fronius is the best in aluminum welding. Their technology is the best in technology. If you're going to weld steel, just flat out weld steel, maybe I'd choose Miller, maybe I'd choose Fronius. But if you want to do more with it, then Fronius is the way to go. And Eli's going to demonstrate that. And there again, I'm all about you guys getting the right equipment. In the cobot world, there was about 90 new cobots introduced at FabTech this year, or in the last year. 90 new cobots. China will private label anything. Okay? But what I've got to show you as well is Fanuc is the only company that has an 8-year zero maintenance and a service for life. And your customer chooses the life. You guys choose the life. If you want to run that for 20 years, Fanuc services it for 20 years. Is it free? No, it's not free. And they only have a 1 or a 2-year warranty, but an 8-year zero maintenance. That means there's nothing to do to that cobot for 8 years. How did they come up with 8 years on that? Well, what they did was they took the yellow robot, and I think their maintenance is 3 years on the yellow robot, and a cobot runs much slower, and so it wasn't as hard on the servos, and they said, we'll give an 8-year zero maintenance. There's no other cobot manufacturer in the world that does what Fanuc does. So if you want the best, it's the best. When it comes to the cart, we have a lot of accessories going around the bottom, because what we want in my own fab shop is everything to be there for my welder. When I say for my welder, let's go back to robots and cobots again. So a robot, an operator runs it. A controls person programmed it. On a cobot, my welder, the guy that is the welder, he programmed it. He programmed it to run 20 parts. No problem. Programmed it to run 1,000 parts. No problem. Can I run high production on this? Absolutely. Can I keep up with a yellow robot? Welding time is welding time. But from the time I stop welding to the time I strike an arc, this is going to be slower. Let's talk a little bit again about Fanuc's cobot. Fanuc's cobot runs in a collaborative mode, 1,000 millimeters a second. A yellow robot runs 4,000 millimeters a second. Okay, so it's only 25% the speed. However, I can also run the collaborative robot in non-collaborative mode at 2,000 millimeters a second. But I got to put an area scan on it so that if I enter the area, it slows down. So we do that, not a problem. But I just want you to understand that Fanuc's cobot will run in a non-collaborative mode and a collaborative mode. We have a system for industry, and the company would like the headstock tailstock. So a headstock tailstock means that I have another axis, so there's 6 servos on the robot. I have another axis out here, makes it my 7th axis. In the robot world, we call that an aux axis or an auxiliary axis. So this one has a 7th and an 8th. And an industry customer called up and said, I want this system, but I want it with a collaborative robot. Can I do that? Absolutely. They wanted to ease of program, and they didn't want the guarding, but they still wanted a collaborative robot, and the speeds are still, because of how much welding they're doing, the speeds are still there. So they didn't sacrifice much time on the non-arc time, if I could say that. So, on the industry side, we offer a lot of products. On the education side, we can offer these products, but we also look at it and say, what does education need? How do they need to teach in order to prepare the student for that? If you go to my website and you look at the program overview here, and you scroll down to say, view the Fanuc grant, there's an MH for material handling and an AT for ARC tool. Today, in this session, we're talking about ARC. We're going to be talking about the other later, the material handling side. But in the ARC side, if you do not have my system, the mod weld system, with the Fanuc robot in your school, you are eligible for a $403,000 grant. That's huge, okay? You might have qualified for a grant on the material handling side, and I believe that grant is about $290,000. If you did, you still qualify again for the $403,000 grant. So I want you to understand there's a huge incentive for that. I've got one other thing to talk about, and that's the Fronius grant as well. If you buy the Mod Weld system for education, so sorry, anybody that's here for industry, close your ears, you don't get this, you don't qualify, okay? It is what it is. So, education special. But if you buy the Mod Weld system right here, you get a $403,000 grant from FANUC, but if you buy it with the Fronius power supply, Fronius is also giving you a Transsteel 2700 or $2,500 credit towards something else. And you'll see the Transsteel when you're out here as well.
will.
So now you qualified for a $403,000 grant, not cash. It's software, it's a lot of things, but then you also get a handheld for free. Just want to bring that up. While we're on this page, if you want to snap a picture, APT is offering a conference on November 19th or 20th. It's the same conference, and it's with Fronius, Miller, FANUC, APT, Hypertherm. How many of you guys have heard of Hypertherm? Cutting. Okay, so plasma cutting, the #1 cutting in probably the world, the name brand is Hypertherm. So before we go out on the floor, you will also see that we have a Mod Cut. This Mod Cut is with Hypertherm. So we can also robotically plasma cut. So if you're 2D cutting laser or plasma in your school, you're doing flat things, it probably has a Hypertherm cutter on it, but may not. But that's great. But if you want to do 3D, you want to do I-beams, you want to do tubing, you want to do profiles, you want to teach that student that, then we also have a Mod Cut, which is available to you guys as well. This was just launched about 2 weeks ago in the industry side, and it'll be launched in the education side as well. So, any questions you have in welding and in products and in education or industry? Any questions at all? Any questions about APT? We're going to go out on the floor and we're going to see some live demos next, which is really cool. Okay, Eli, I'll turn it over to you.
Okay, I think with the amount of people we have, we're going to probably do 2 groups. So we'll probably just split it. One will be with us on the Mod Weld, and the other will be over with Fronius right here, live welding and everything like that. They're going to go through and explain all that. So if you guys would, we're going to go outside and keep it going.
and the
Tony in here for just a second to kind of help fill me in.
Fronius and the Fanuc grant.
Hey, Tony.
Yeah, I'm gonna write down what I need to do. Yeah, yep.
Hey, Tony, whenever you get a sec, I could use you.
Okay.
Okay, sorry. What? No, he's. The Fanuc CRX10 with the Fronius power source. In this case, we're going to use a Fronius. Why is because it is the premium, the best of the best. Currently, right now, we have a push-pull system. If you guys have ever welded aluminum before on some 4043, you know that a push-pull system is going to be typical because if you kink that line in any which way, for example, how easy and brittle it is. On the teach pen itself here, I can winch it out. And I can break off some filler metal that easily. That's why push-pull is very is required when you do most aluminum, just to kind of keep everything steady and set up. But with this too, what makes it very special is the fact that the Fronius the motors go forward and backwards. So not only can, if you can't see it, let me help you out. So with the Fronius itself, Tony, I'll need a little filler in here in a minute.
No problem.
So as you can see, I have some filler wire right here that I just pushed out. I can also suck it right back in. Pretty cool feature. On most of your standard short circuit MIG, you know, all you're gonna do is push. You're not gonna be able to retract it in any means. It's all about the push. So Tony, I'm gonna try and get a program set up.
So while he does a program, I'm gonna tell you a little bit about the features of the equipment. It's easier to look at it here than it is to see it on the website and understand it. First off, on a collaborative robot, one of the most important things is the dress out. So to understand a collaborative robot, some people think a collaborative robot goes in a neutral position, and that's how I push it around to program it. Actually, it doesn't go in a neutral position, because if it went in a neutral position, it would just fall like a wet noodle, okay? So we set this up with what's called a payload. And a payload means if I put 10 pounds on the end of it, I don't want it to drift down. So I set it up with a payload that says this is my position that I'm holding 10 pounds. In the welding world, we have to do the same thing. You can see this green roller system up here. That's to allow the torch to go through. Because what will happen is if you don't have a roller system, then the robot will come up to a position and the torch is actually pushing on it, and you think it's drifting. Actually, the robot thinks it's getting pushed, okay? So everything we do when we program this is we program it by moving it by hand. So in the yellow robot, we use the tablet or the teach pennant and we push the arrows. And in the collaborative robot, we actually move it. Now, Fanuc software, so we have what's called a Fronius library in the Fanuc software. So everything on the Fronius also shows up on the tablet, which is really nice. And then we have two buttons over here, a teach and a jog mode. And the teach and the jog mode is when I want to jog, I jog it, and then I want to teach, I hit the button, and you don't have to take your hands off to go to the tablet every time.
And I will demonstrate that here in a minute, and I'll write a program right in front of you. I'll weld it and everything. It's going to be pretty cool. Some other things to talk about, the Fronius specific stuff, why that push-pull system to where we can go forward and retract is so special. We can do stuff as we would TIG weld, as all y'all are familiar with, how you're going to dip in some filler rod, pull it away, dip in as you go through the torch. Same thing applies here. Since my motors can go forward and reverse, I can dip in, short circuit out, get back in. I'm not always constantly feeding into it, adding too much heat. I can keep it a lot colder, and we can do some really fun special stuff like welding galvanized steel to aluminum. Okay, this is your automotive stuff.
Wait, did you say you're welding galvanized steel to aluminum? I want you to hear that.
Galvanized steel to aluminum. This is not a trick. This is 1/4-inch aluminum steel, and this is a nipple that I went and bought it from Home Depot, chopped off and welded it up. We're going to do that right in front of your eyes. This is galvanized steel that I just went from Home Depot and bought. How we're able to do that, like I said, is we're able to keep that weld cold enough that we don't burn through and we don't melt through that steel. But we'll show that, and to kind of also show you guys as well being a welder, you have to be able to, you can adapt on the fly pretty easily. This robot does not. You're going to teach it how to do everything itself. A really cool example that I give is first one that I had done where you can see the ending there. It gets really nice and hot, big and fat. So that is a correction of 25 inches a minute to 35 inches a minute. We're able to keep that weld puddle a little bit more uniform, more organized throughout. That's something that normal welders aren't going to know, okay? I didn't know, so I started playing with it and everything. I'm an industry guy. So it's going to teach you a whole lot more and a whole new depth of welding and how to control a weld puddle and actually defining what it's going to take to make a simple weld all the way through and through. You'll be able to say that and nobody can come against you. So without further ado, I'll kind of give y'all a little quick demonstration. If you kind of get more towards the front here, you can see through the glass.
While he's doing that, this screen is sold as an accessory
This is an
as
add-on.
well. So you sometimes Eli will have it, or you guys in education will have it in its own booth. But if you don't, there's a screen available to you as well.
Absolutely, absolutely, great point. All right, let's see if I got all the kinks worked out. So what you'll do is you'll set up your program, you'll write your program, and I'll teach you here in just a minute how easy that is. Once you have your program, you're going to give it a weld schedule, and you're going to define everything on the power source itself. So right now, here we are. We're going to weld steel to aluminum. Let's see if I got it right. No tricks, no nothing like that. This is all live in front of you.
Eli, can I ask you some questions on this?
Please, hey, success.
So first off, how many of you guys are from the welding side? Anybody from the welding side of the school? Okay. So when you go back to your schools, if you're not, and you tell the welding instructor, we just went galvanized to aluminum, they're going to say it's not possible. But the question I got for you is, what wire did you use then? Did you use aluminum wire or steel wire?
So this was an aluminum filler, 045, your standard stuff that you're going to use and all your applications there. No tricks, no trade. We can talk about two things. So we can talk about the teach pennant itself, how easy it is. With the collaborative robot, we use just a standard iPad. Okay, you can use any iPad you want as long as it's got the Fanuc app unlocked and everything. This is simply a housing itself that it goes on. It's got an e-stop for you there. We also have an e-stop here. But as you saw, let me tell you what, let me show you this right here. So talking about the collaborative robot, right? Like how it's gonna go through and do its thing. If I happen to be here, I can sit here and work all I'd like. And if I bump it, she stops, okay? A very quick reset. Oh, sorry. I clicked the wrong button there. And we're back to welding. So it's made to work with a person, not against a person. It's going to elevate and bring up a skill level of your welding potential and all your welders there. It teaches them a whole new way to think outside the box and make this arm a part of themselves, okay? But let's go a little bit further here on the teach pennant itself. It's very simple, very easy icons. You'll simply drag and drop through everything. So I'll go to select a program here. We'll go to something easy. But it's very simple. You can simply drag and drop different icons, and you'll learn what each one does over through your course. When you purchase this as well, you're also going to get the ModWeld specific class that APT offers and everything, and they're going to teach you everything like that. You have many icons to choose from. They're very simple. We don't have to do a lot of coding here. We have simple icons that you can run through and teach, and you just drag, drop, and place. So very simple there. In front of y'all, we'll do. Tony, go ahead and fill in for just a second. What I'm going to do is we'll do a weld. We'll do a little fillet weld here, and then I'll make another program right in front of y'all really quick.
So on the Fronius, if you look at the website, there's 3 softwares, PMC, CMT, and ILS. PMC in the industrial world is the number one. 80% order it with it. So we automatically have it on it.
Pulse material control.
Pulse material control. So it's not even an option. CMT is a software that Eli's using, but CMT you have to have the push-pull. So if you wanted to add CMT later, we have to have the different torch and be what's called CMT ready. If you're going to weld aluminum, you need CMT. You need the push-pull, I'm sorry. You need to be CMT ready.
So CMT being that cold metal transfer, that is this process right here where we actually dip in and pull out in various ways too. You also have different synergic lines that it'll come up with Universal being more geared towards the handheld stuff that will actually physically handheld weld. Dynamic for your robots, and then we have several different mixed drives. Mixed drive is pretty cool. This is going to be on the PMC side, but with a mixed drive, it'll mix up 2 different welding procedures at once. When we do vertical uphill, typically we're going to weave that torch in and out the whole way up. In this case scenario on the PMC mixed drive vertical uphill, it will short circuit in, pull out, spray, flatten everything out, go back in for a short circuit. So it'll actually transfer very, very quickly back and forth, and we can stay that torch straight up and down the whole way. It makes it much easier on the operator. So simply an operator could, if this was on the traveler cart, what you might see a lot in industry is going to be a lot of that traveler cart too. There's a lot of viral videos and stuff like that in Japan, and where they have it on like a big tank track setup, and they have a cobot and they just wheel it around, teach it a start and an end, and it'll weld. So in any case scenario, if you're in a giant fabrication shop where it's a big seam and you want to make it look really nice, one big weld, we could wheel that over, clamp it down, teach it a weld start and a weld in, and as long as the welder, the programmer, knows what he's doing there, perfect seam weld every time. So that's what you're going to see in those real world applications, where being in a big warehouse where it needs to move. You could have it on the 7th axis with a track system, like he was talking like that. That's another thing that you're going to see a lot of. Let me make sure I got this guy. Go ahead.
Folks, if you're doing soccer,
if you want to get them, you're going to get some people do hands-on stuff.
Afterwards, not during.
You don't have, like, well, you get a little bit anyway. So,
Okay.
So 10:25-ish, 10:30's coming.
Okay. No problem.
Need to grab some.
So, sorry guys.
Oops, I'm sorry.
So he was nice enough to cover, like I said,
Jim, how you doing?
we got multiple
No, let's
settings
call.
on the Fronius itself. We have your standard
I don't
MIG,
need
we
you
have your
now, but I do
pulse,
need your number.
and we have that PMC, pulse material control, and that CMT. Really, really cool stuff. The CMT already integrates a low spatter control, keeps it really down to a minimum. As y'all saw, y'all didn't see a whole lot of
get my
spatter
stuff
coming
out of
around,
the way.
very minimum. It's a really great option there.
Joe. And you're on my list.
It's about a 1/10 of a second. The Fronius
Ben and I, my
computer itself in there is going against whatever resistance you have on the weld. It's trying to manipulate and make sure that it always has a weld bead. If you were to pull away, get too close, everything, it's going to adjust on the fly. So definitely a really cool setting there. I'll give y'all a quick PMC. And everything again is touchscreen. I tell you guys, if y'all want to get a little closer here, let me show you guys something here. What is cool is what gets a lot of instructors fired up and and is definitely really good for the education and the basic welder that may not know what settings are going to do what, right? It's a whole lot here. You know, I have multiple different settings for just one different weld that I can make. So the cool thing is, if all you know is material thickness, like in this case, that's 0.025, click that in and it will give me a generic amperage and wire feed speed. That's pretty normal. That's going to be on all your other stuff. What is different here is that when you click it in, the more that I adjust it back and forth is going to show me more of a weld profile that I'm going to get, okay? Well, I'll go a step further there, and we can start talking about a frequency on our pulse itself, to where when I elevate it, you'll see you get more of that stacked dime look, and the more I increase, we can tighten everything up. So it's a very visual aspect, as well as things that might go over your head, like arc length correction. If I dial that up, you'll actually see undercut coming into play right there as well. So it's going to show you a whole lot there of what can be done. So as it describes and tries to help a student understand visually wise, this is going to help that kid a lot more by what adjustments he makes is going to do what. So that's a big aspect there that I like to always showcase about Fronius specific as well. And it's all touchscreen. You can do there, and you can do, we can define our stops, starts, gas setups, the pulse itself. We can do a lot of really fun, tricky stuff. We can literally manipulate that weld puller to do anything we'd like it to do. That's why something I haven't talked about is your current customers. Your current Fronius customers here in Texas. You have your South Texas sales rep right over there. His name's David Brown. He was nice enough to give me his list of all industry partners. So their best customer at this very moment is SpaceX. SpaceX does a lot of different alloys, a lot of very high frequency TIG stuff. Their high frequency TIG with Fronius is the best. It can go up to 10,000, which is pretty unheard of. Sounds like a dog whistle. It's pretty annoying, but it can penetrate very, very well. So their current customers would reference be Tesla, SpaceX, Toyota, Ford, Harley Davidson, Rivian, Lockheed Martin, NOV, Baker Hughes, John Deere, and then Relative Space actually uses, sorry, it's compressor. Relative Space actually uses the Fronius to 3D print their booster rockets and stuff that they have there. So that's pretty cool. That is to showcase that Fronius is here hardcore in Texas. And so in education, it would be very, very a smart thing to diverse and show a different welder as well to the student, because they will be seeing
Not just having Lincoln and Miller.
not just having Lincoln and Miller, because if they do something like that high frequency alloy stuff, they're gonna be seeing a whole lot more Fronius. It's making a big impact here in Texas. So let's just kind of give you all a complex there. Let me double check my program here really quick. Any questions, guys? No, no, sir. No, not yet. Just one second. It's always good to double check your programs, because I promise you, you can make mistakes very quickly. Looking down. Everything's decent, right? Okay. Not terrible, not terrible. Okay, so we'll do live. So now I have set up my program. This is already pre-made one. I'm gonna make one for y'all here in just a second. So now that I have set up my program, I'm gonna come to my welder and make sure that I like everything about it. It's about right. About 6 is fine. Okay. All right, let's see what happens. You guys ready? There you go. So this is the PMC side. Just doing a little, it's about a 6 frequency.
Come find me after. We'll get you set up with our tech, so we've got space set up for you. So we are doing the gold 201 and 101 certification here today also, and tomorrow. So.
Thanks, David. It's great to be with you this morning, and I'm Jim Wall, Executive Director of SOC for the Smart Automation Certification Alliance. I'm going to start off talking a little bit about the numbers that we're seeing for some national reports in terms of the need for people with skills that our certifications are designed to around. So the number one reason that manufacturers and other organizations give for not making an investment in new smart automated technology isn't the lack of funding. It's the lack of skilled workforce. They're worried about, do I have people that can maintain, install, and operate these automated systems? And that's a critical shortage. If we look at the numbers across the country, between now and 2033, the manufacturing industry needs as many as 3.8 million new people in the industry. And if we keep going like we're going, we're going to fill the green sections. Well, what about the 1.9 million that are additional jobs that are not going to be filled if we don't ramp up and get more training programs, really putting out a lot more people with skills that are needed, and really, not just manufacturing, but all industries are rapidly changing with these things, Industry 4.0 related, the blending of the cyber and the physical world. AI is impacting a lot of things as well. So there's a challenge. How do we ramp up programs? University systems aren't putting out people with these kinds of skills. The biggest portion of the educational community that is the community intelligence system, and beginning in our high school programs. So there is a lack of smart manufacturing education programs across the country. There are quite a few here in Texas, but there are also a lot of places around the country where their programs are not really at the Industry 4.0 level yet. So that's absolutely a challenge. One of the solutions that we've been working with some of the leaders and some of the folks in the government sector is to look at a strategy that would include industry recognized credentials to provide pathways for more people to get more skills. And we recognize that if we have a modular curriculum and people and companies can do things in small chunks, that it provides a pathway for especially small to medium-sized companies to get started and get on that path of continuous improvement. And so there's been a significant shift, I think, in thinking in terms of how we might be able to ramp up numbers across the country using industry stackable micro-credential. So, one thing we like to talk about is what is a micro-credential? Well, the whole idea with SOCA to develop a platform of stackable micro-credentials came out of our first industry technical work group that we had back in 2017, where we asked industry leaders from a lot of different companies who came together to really talk about, we didn't have named SOCA yet, it was to really look at the problem of this Industry 4.0 challenge it was facing, and at that time, primarily manufacturers who came together, and they said that we asked them to envision what would work within your own company to more quickly be able to upskill your existing workforce.
Okay.
For the live stream.
Sorry.
So, the comments that came back from the group were, well, we need something that's very granular, very modular. There's no one size fits all. Every company is a little bit different. And if we could send our people for training for a week at a time, that would be, and we could repeat those trainings over time. And if they could get a small credential and we could stack that and create pathways, that would be, much more efficient for us to upskill our own internal workforce. So that's what's going to set us down on this path of developing these stackable micro-credentials. We kind of use that 40-hour window as a rule of thumb to determine how much content should be in each of the micro-credentials. And it turns out that 40 hours, give or take, not only works pretty well in an industry setting, but it also works well in an educational environment because it's these small micro-credentials can be embedded in individual courses at the technical and community college level, which allows people to get an industry-recognized credential as they're moving along through their experience at a community or technical college. And we think it's important that these micro-credentials be based on the needs of an occupation, not a particular vendor's equipment or technology platform. So, we try to be agnostic. We look at what are the skills that the person needs. We look at competency areas, and within those competency areas, the knowledge indicators and performance indicators that would discriminate between a person that was truly competent with that content or that technology area versus those that weren't. And it doesn't, we look at the equipment that's needed to do the hands-on performance assessment needs to have the capability to assess the skills that are called for in the standard. So we develop a capabilities document for each of our credentials, and that's what we use to determine is the equipment usable for that particular certification. So we are a nonprofit educational foundation. We were actually incorporated right in the 2017-2018 timeframe. And our mission is to work with industry experts to develop those skill standards, those documents that outline the skills and competencies that a person needs to be successful in different occupations. And from those standards, then develop a certification program to certify individual skills against those standards. Currently, we have 395 member organizations across the country, about 22,000 individual users, and just about 60,000. We'll do 60,000 this week. These are last week's numbers, and both our membership and the certification numbers are increasing as increasing rate as we get more programs and companies around the country that are doing the certifications. I'm going to click through some couple slides here that show some of the companies who have been involved in helping us develop the standards and certifications. The first slide, there's a lot of transportation-related companies. We've been working recently to develop standards and certifications around the electric vehicle manufacturing and also the lithium-ion battery production. So we've had, actually our largest technical work group was in December in Detroit, where we had over 100 people from industry came and participated. There's intense interest in all the manufacturers and the suppliers in the automotive industry about, how to ramp up their existing workforce to be able to move into the EV space and the battery production. Other companies have been involved. You'll notice one thing about the number of companies that have been involved and the different industry sectors that are involved. It's not just manufacturing, but it's a lot of different types of organizations have been involved over the years. I'm going to talk about Amazon in a minute, but there's oil and gas, food processing. One of the names that's known pretty widely in the industry is Rockwell Automation. That's the Allen Bradley folks. Rockwell's been involved from the beginning in having some of their technical experts involved in our technical work groups. And after a couple of years of involvement, they came to me and said, Jim, we want to get involved with SACA in a bigger way. We keep going to these technical work group meetings, and around the table are a lot of our major customers. And we like the idea that it's vendor agnostic and
It's based on skills for an occupation. And remember that Rockwell has an internal organization that does training and certification for their customers, and they get Rockwell specific certification. But they recognize it was important for them to be involved on an industry-wide effort. And so it was a little bit of a hard sell for some of their folks internally, but their CEO made the decision to have them come on board as a platinum sponsor, and certainly we appreciate it. But our certifications aren't based on the Rockwell platform. I'm a Penn State guy, and Joe Paterno used to have a saying when he was talking with alumni trying to get them to donate. He said, "I want your money, but not your 2 cents." So I used the same thing with Rockwell. I said, we appreciate you coming on board as a platinum sponsor, but you get one vote at the technical work group meeting, and we're vendor agnostic. It's not going to be centered around the Rockwell technology platforms, and they were okay with that. So recently, we've been working with Amazon. I notice the letter is a little hard to read, but it's interesting. Our relationship with Amazon has been going on for several years now. Initially, they were working with 5 technical colleges across the country on an apprenticeship program for their entry-level maintenance, reliability, and robotics technicians. They would send these folks to a technical college for 16 weeks of full-time study, 40 hours a week. And during those 16 weeks, the apprentices have to complete 8 of the micro-credentials at the gold level. And then they get sent to different facilities around North America to complete their apprenticeship, an additional year of on-the-job training. And recently, they've expanded that initiative to include all of their technicians in North America. So they're creating a system where the level 1 technicians are going to need to get 7 micro-credentials that Amazon identified to qualify as a level 2. And there's a different stack of credentials that are required for a level 2 to move to a level 3, and a different stack for folks to move into automation engineering positions. And that's rolling out this year, going into 2025. So, we're going to see thousands of technicians in North America doing the SOCA certifications. And originally, when we worked with them, everything was top secret. We had to sign NDAs. You couldn't talk about it. You couldn't mention Amazon because they thought, they were the only ones in the world that had this problem, and they had the solution. But recently, they've been willing to open up about it, and we've kind of been working with them to convince them that, listen, you need to be open about it because there's technical colleges all across the country that could be helping you, supply your facilities with skilled people. Let's work together and build the capacity in communities where obviously you have facilities, and that's virtually all over North America. So some of their senior people have agreed now, and we get a letter. This was a letter that went to the Secretary of Education in Maryland to get our certifications approved on their approved list in Maryland for schools to get increased funding. And they are much more open about it. That's I talked about the apprenticeship program. So some of the features of our certification program we think are very important is, number one, everything we do comes from our industry technical work groups. These are volunteers that their companies support them to come and participate in technical work groups, and they determine what the content is of the standards, and they come to consensus on, what are the most important things that need to be part of not only the written knowledge assessments, but also the hands-on performance assessments, because you can't test everything. So we work with the industry folks to have them identify what are the key things that we could involve in a certification program that are really going to make a difference to identify that competent person from the incompetent person. And the other thing, from the beginning, we felt it was important that we were compliant with the international standard for personnel certification bodies. That's the ISO 17024 standard. And one of the things that some certifications organizations have trouble being compliant with that standard is that you have to have a firewall between your training activities and your certification program. You can't require someone to buy your textbook, buy your course, in order to sit for your certification and be compliant with the international standard. And that's easy for us because we don't get involved in the actual training of individual candidates. We see our role is to convene the industry, develop the certifications, do a national validation to come consensus around the country, and we do some international validation work as well, and then have those standards be available to members of the Alliance to align their training activities to the standards that literally hundreds of people in the industry have weighed in on. And we don't have a standard course or textbook or anything like that that is required. For all of our certifications, there's two levels. There's a silver and a gold. The silver is awarded to candidates who successfully complete a written knowledge assessment that we deliver online in a proctored environment. So someone needs to supervise the individual when they're sitting behind a computer to take the test. The role of the proctor at the silver level is just to make sure it's the right person sitting behind the computer and they're not getting any help along the way. The gold level certifications are awarded to candidates who successfully complete that written knowledge assessment, but then additionally complete hands-on performance assessments where they actually have to demonstrate some skill and competence using that technology. These assessments are scenario-based, so typically there's 2 or 3 different scenarios that the candidate will have to complete. They're things that common things that a technician would see on the job related to that particular technology. And in order to proctor the gold level certifications, these are normally proctored by the instructor or the trainer. That instructor or trainer has to have the gold level certification themselves first, then they can proctor other people at the gold level. So at least one person from an organization is going to need to go somewhere else, get that gold level certification, then they can come back and certify obviously candidates in their program, but also other instructors and trainers that they might work with. We try to make that as affordable as possible, and we know a lot of colleges have adjunct faculty that come and go, and we don't want to require everyone to have to go somewhere else and get that gold level certification, but at least one person has to do it, and then they can certify other people within that organization. Within our certification program, we really have 3 levels, if you will, of credentials. We start out on the left-hand side here with associate level certifications. These are foundational. When this was under development, the industry folks were thinking this would be a great place for high school programs to start, to introduce young people to the world of advanced manufacturing, Industry 4.0 related technologies. So each of these are not micro-credentials. There's 4 different credentials at the associate level. Each one of them, typically at a high school level, is taught in a semester course. Most schools across the country, high schools start at the 11th grade year, and by the time people are seniors, they've had 4 semesters and they've completed the 4 semesters, the 4 credentials. Some schools that have experience at that have now decided to move that back and begin in the 10th grade year so that they complete the certification path in their sophomore and junior years, and that leaves their senior year open for some kind of job experience, internship, school-based apprenticeship program or whatever. The next column over is a specialist level. You'll see a number of common occupational titles. Each of those occupational certifications, specialist certifications, are made up of a different stack of micro-credentials. Originally, when we developed this platform of micro-credentials, we talked about stackable micro-credentials, and a lot of times, especially when we're talking with industry folks, they had a hard time understanding how these stackable credentials could work within their own organizations. So we decided a number of years ago to put them in stacks that made sense in the industry. And again, when people look at that, the light bulbs go off. Okay, so for my maintenance people, here's a path. For my production people, here's a path. That for different occupations or roles that they had within their organization made sense. Then I'm going to talk about the professional level in a little bit that's coming up. So each of the specialist level certifications, I'm going to step through them here. This is the IT system specialist. electrical system specialist, more of an entry level, like occupation. There's a modest number of core required micro-credentials. The operations specialist, the same thing. Robotics system specialist, control system specialists. And you'll notice each one of them has a different stack of core requirements. The automation system specialist, this was actually the first occupation that our technical work groups decided to tackle. And they recognized that this was an area where there was the biggest need in industry across the country, is having individuals that are fully qualified to install, maintain, and operate fully automated systems. And you'll notice there's, a sizable sector, 16 core requirements that are here. Now, if someone goes through a program at a technical colleges and completes all 16 of these micro-credentials, they would have qualified for a number of those other occupations, specialist certifications along the way. When someone completes the core requirements, they're automatically awarded an additional, the occupational specialist certification. Each one of the micro-credential certifications is an industry-recognized credential, but there's also, a designation for the specialist level with those different occupations. And you'll notice also there's some electives for some of the occupations. Here, you'll notice there's hydraulics is an elective. And that's because when we went for a national validation on this, occupational pathway, there were industry sectors that said, whoa, we don't have any hydraulics in our facilities. We're talking about drug manufacturing, food processing, some medical device. There's a number of different occupations where they don't do any hydraulics. And we knew if that was required, companies, are never going to spend money to train and certify people on something they don't think they need right now. So where there wasn't common agreement between industry sectors, those areas were moved to be an elective. It's there for those sectors that need it and want it, but not part of the core requirements nationally. We also have advanced level credentials, and I'm going to talk a little bit more towards the end about some new credentials that are coming online. And the list of new credentials to be developed keeps growing almost by a daily or a weekly basis as things change in the industry and more technologies are being used across the country. I mentioned the professional level. Recently, about a year ago, maybe a little longer now, we announced a partnership between SACA and the University of Wisconsin-Stout on an automation leadership degree. And the large portion of this degree is based on the attainment of SACA certifications. Doesn't matter where the individual earned the certification, they present the certification to the university, and it's the currency for university credit without paying anything. The student has to enroll in the program, but it's the first program that we know of in the world where a university system has agreed to use an industry-recognized credential as the currency for credit. And I'm really excited about this for a couple different reasons. Number one, and this had to be approved by the public university system in Wisconsin, which includes University of Wisconsin-Madison and about 16 different universities. Any one of them could have stopped it. None of them did. So it's an indication that they recognize that across the country, hands-on technical training is done much more effectively and efficiently in the technical college system. And it's very difficult for a university program to provide hands-on training in a lot of these new technologies. So they're partnering with technical colleges across the country that all the technical college has to do is sign an articulation agreement with Stout, and then they can be part of the program. And the academic part of the degree program that is delivered by the University of Stout is this section right here. There's 6 or 8 courses that are all delivered online. They're delivered by the School of Business at Stout and get into project management, leadership, those kind of things. All the rest of it is based on SACA certifications. If we look across the top here, there's 40 credits that would be general education, and they're very liberal. And this is really any kind of academic course that a person takes at a 2-year school. It is acceptable. Then there's another block of 40 credits that is what they're calling the SACA core. And that's we looked at programs around the country that are doing, industrial maintenance, automation, mechatronics, and looked at what are the credentials that those programs are using as part of their 2-year associate degree programs. And those 40 credits. There's an additional level of SACA professional level credits. There's 21 credits, and there's a list of 14 credentials. These are a little bit advanced above what are typically part of an associate degree program today. So we're working with technical colleges to create advanced certificate programs that would sit on top of their associate degree. And then there's the block of courses that are delivered by the business faculty. And the beauty of this system is it's simple. There's no money changes hands between organizations. The technical colleges charge tuition for whatever it costs for them to deliver the courses for the certification. And the students pay the online tuition for the courses they take online from the University of Wisconsin-Stout. And because it's an online course, there's no out-of-state tuition. And we think this is a model, and we're already seeing, we have 2 universities in Ohio that recently announced programs that are very similar based on this model. And we've been in discussions with folks in other states that are also looking at this. And we like it, and our industry partners like it, because it really is a very cost-effective career development program for companies to be able to have a pathway in their own communities. People don't have to leave, they can be working for them, and have a pathway to not only that baccalaureate degree, but there's a direct articulation into 2 different Masters of Engineering programs at Stout that are they're all online. And we just use the tuition rates in Wisconsin. So for a person to go to one of the technical colleges in Wisconsin, do all the SACA certifications, and then to pay Stout, it's about $25,000 total for a baccalaureate degree, which is crazy compared to what tuitions are at a lot of universities around the country. And if a person, say they're working for a company and they want to get that master's degree in engineering, the total cost from starting at a technical college through the master's degree is about $40,000 inWisconsin. Those numbers are going to be different. Yes, sir.
Are you talking to any schools in Texas?
We have. We've talked with folks at Texas A&M and some others. I'm not sure how interested they are at this point yet. It's Texas A&M is doing. Some of you probably have been involved with some of the instructor training that they're doing, and they're ramping up around SACA certifications. At least the Texas A&M Extension organization is involved. And I know Warner is actually directly involved with them here too, so he probably knows a little bit more about that as well. So, I just think this is a model that is worth looking at. And, it was interesting. We had to get political support in Wisconsin to get it approved by their state system. So there's 25 CEOs of some of the major manufacturers in Wisconsin all signed letters of support, because they recognize that, there is no pathway now for them to get technically skilled management people unless they grow them themselves. And this is a pathway that they could adopt and have a career development program to really help get those technically skilled managers that really understand the technologies and can be the next generation of leaders. We recently, I'm going to talk now about some new credentials that are coming online. We just recently completed work with CESME, the Clean Energy Smart Manufacturing Innovative Institute. This is one of, I think there's 28 or 29 national institutes that are either funded by the Department of Energy or Department of Defense. CESME is funded by the Department of Energy, and they worked with us and Amatrol. Their whole mission is to help small to medium-sized companies get into the world of smart manufacturing and try to break down the barriers, the cost barriers for small to medium-sized companies to be able to use some of these new tools. So they've developed some really cool, relatively inexpensive, like digital twin libraries where companies can sign up and become a member of SESME and be able to very cost effectively develop a digital twin of their operations or some of their lines. But they also recognized that they needed to find a lower cost way for companies to really begin doing training around smart manufacturing. So that they worked with us to convene technical work groups to develop these 4 credentials and standards. And once that was done, they worked with Amatrol to develop a tabletop trainer that includes a lot of sensors and communications ability, data collection, so that companies have a low-cost way to begin training their folks around the whole idea of a connected enterprise and how to use sensors, how to collect data, how to analyze it, and most importantly, how to visualize that data, and also, kind of the basics of cybersecurity for operations folks. We have expanded our work with some of these national institutes. We are continuing an additional project with SESME to develop additional credentials that will add on to that list of 4 that were developed. And then, we're also working in cooperation with SESME and Symantec. Symantec is another Department of Energy funded innovative institute. They focus primarily on cybersecurity. So we're going to be working with them over the next year and a half to develop additional cybersecurity credentials. And the Symantec folks have indicated they would like us to work with them to develop a certification path that was analogous to OSHA 10, that there would be, a basic set of SOCA micro-credentials that would be, a common expected skill level for everyone in a manufacturing or everyone in a facility to have that basic cybersecurity training and have a certification to go with it. So whether that's going to happen or not, I don't know, but we're working with them. We also, another one of the innovative institutes is MXD. These are folks out of Chicago. They're funded by the Department of Defense, and we're actually having a technical work group there November 15th in Chicago, looking at a pre-metaverse technologist and a data annotation position. Where they're looking at the metaverse and augmented and virtual reality kind of things that is a little bit beyond what a lot of companies are doing now, but it's certainly something that they see coming in the future. So we're working with them. We recently also began working with the Florida Semiconductor Institute. This is a group out of the University of Florida that the 2 faculty members leading that organization are kind of world-renowned in chip manufacturing. And there's over 120, I live in Florida, but how do you know there's over 125 companies that are part of the Florida Semiconductor Initiative that are involved in semiconductor. Okay, so there are semiconductor initiatives going on a lot of different places around the country. We decided to begin with the folks in Florida because they're able to convene large numbers of companies very quickly. And what we're planning to do is get some draft standards from that group and then go to various locations around the country where there are chip making interests and do validation meetings. So we did actually publish and have on our website a semiconductor operator certification pathway. And the additional work that we're doing with them will be at the technician level, and that's going to come over the next year. We also have been working very closely with Endress Hauser on instrumentation and process control, and I'm going to talk about that new pathway that has been released in cooperation with them. So here's the instrumentation process control pathway, looking at smart instrumentation and smart process control. These standards some of you might have heard about or participated in one of the technical work groups that we did at it was held at the Andrews Hauser facility in Pergoland, on the other side of the city, somewhere around. It's around Houston somewhere. I know it was there, they were involved in helping bring the industry together. But the standard was developed not around their technology, but they facilitated getting the right people at the table to develop this pathway. And there's been a lot of interest. Obviously you think of oil and gas, but also food processing. There's a lot of bio pharmacy and other bio-related industries that are also very intensely interested in getting people with these skills. Eli Lilly in Indiana is looking at it for their bio and drug making facilities. So these have just been published. Some new credentials they're coming online next month and in December. We've got a whole series of credentials that will be going into the pilot phase. That means the tests have been completed, the hands-on performance assessments have been developed, and now we're in the pilot phase. So schools and companies can participate as a pilot organization, and that means you have available to offer these certifications in your programs. The caveat is, while it's in pilot, the individual doesn't know whether they passed or failed when they complete the test. We need to have a number of people complete the exam so that we can use that to statistically analyze the results to make sure it's valid and reliable, and in order to set the cut score. So as soon as we get enough people and we can run the analytics and statistics on the test item analysis and set the cut score, people are awarded the credential retroactively if they met the cut score. So with that, I'll kind of wrap up things a little bit. We think it's really important that our certifications provide labor market advantage to individuals. If they're not getting labor market advantage, it's a waste of our time and your time and their time, and we don't want to do that. So, we think because everything we do comes from industry experts that develop the certification and the standards, that becomes relevant to the industry, and that's really paramount for us, that these certifications are by industry for the industry, and that it's tied to occupations. We think that's also very important, not tied to a particular vendor's equipment or training program, that it's based on the needs of the occupation. We have a flexible system, so any school or company can pick and choose which credentials fits their program or fits their particular role within their organizations. So even though we have those credentials laid out with the specialist designations, people can pick and choose what fits their program, and a lot of times, start small and build their program in a school-based situation. And for a company, having that ability to very specifically pick the credentials that meet the needs of the individual and the role is critically important. And we also do it at a very low cost. From our inception, we wanted our certifications to be free to the end user. So we operate on a little bit different business model than most certification organizations. We operate on a membership basis. So a school or company joins the Alliance. Once they're a member of the Alliance, they can offer an unlimited number of certifications to the people that they train. On the educational side, for an educational membership, for a high school program, it's $500 a year for a high school. If there's multiple high schools in the district, it's $1,000 for the district. I'll be honest with you, we didn't know about Clark County Schools in Nevada when we put that in place. Clark County Schools cover 75% of the state in Nevada. So for $1,000, Nevada's getting a hell of a deal. And there's another school district, Northern Nevada, that has the other 25%. So for $2,000, the whole state is covered, basically. But we're okay with that. We did that intentionally to make it very affordable for especially urban systems, where historically there has not been the investment in technology in programs. So we did not want that to be a barrier. So for a college program, it's $2,500 a year. And that's for the whole college. It's the workforce side, the academic side, whatever training the college does. Normally, there's multiple programs, especially in the larger colleges. There's multiple programs that could use these credentials. So once the college is a member, it's open to anyone there. On the industry side, there's a sliding scale depending on the size of the company, starting at $500 for a company of 100 or fewer employees, maxing out at $3,500 for a location of 500 or more employees. And that's it. I mean, that's that one annual membership. And the only additional cost is that one-time cost that a school or company would have to have their instructor or their trainer go somewhere else if they want to do the gold level certification and get that gold level certification and bring that back to their organization. With that, we are getting involved in instructor training. We think that's a really important role for us, especially at the high school level. There are very, very few high school instructors that have any kind of hands-on experience with a lot of these technologies. So, we're working with some of the leading technical colleges across the country to have them become SOCA regional instructor training sites. We mentioned the program we're doing with Texas A&M, and the goal there is also to expand that and make those resources available at other locations, certainly around Texas and around the country. And with that, I'll take a breath and see if anyone has any questions. I'll be happy to try and answer them for you. I think we have 3 minutes left.
So you say the Amazon is part of your organization?
They're not part of it. They're using us. They're a member. Yeah.
All Amatrol facilities? Because I've heard that Dallas has it, but Amatrol in Houston does it.
Well, the Dallas College is one of the 5 sites that are doing the training for their level 1 apprenticeship program. They're expanding that. They need to double the number over the next 3 years. So they just told me on Friday they're looking for other colleges and other locations. But they're also, with this expanded program, internally they're providing training and certification to all of their technicians across North America, beginning now and through the next Amazon is, right?
Because we try to talk to them. But no way.
It's a big organization, yeah.
Hey, Jim. Apologize. We got about 2 minutes, actually,
Okay.
about 1 minute.
Okay.
So I don't know if we're gonna wrap up.
Yeah.
We gotta start pulling people in.
It's a quick question. We're in the industry, of course, we're Mars Wrigley.
Yeah.
And we've got a lot of Amatrol equipment that we're using. But if I understood you correctly, I could actually take somebody out to a line and
Right.
test them as long as that line had all of the equipment
Exactly.
involved.
Yep.
In it. So I could train them on
For all-
laboratory equipment and test them in the real world.
Exactly. For all of our certifications, we develop a capabilities document. So the equipment you're going to do the gold level certification on has to meet the capabilities. Doesn't matter whether it's in a trainer or a piece of equipment on the line. Most companies that are in production would rather do it on the training equipment because they're tied up on their lines normally. But and we have colleges that over the years have built their own trainers. And work them. They just have to tell us what's on board, and my folks have to determine, does that have the capacity to test what's called for in the standard.
So as long as it meets those standards, it doesn't matter what the equipment.
Exactly.
So SOCA has to vet that out, for sure.
Yeah, well, the program or the member organization, for each credential that they're going to do the gold level on our testing portal, they enter what equipment they're going to use for that credential. One time. You have to do that one time. And then we determine is that equipment meets the capabilities, and basically flip a switch on so that it would allow you to do the gold certification, in your organization. So I'm going to do as I'm told, and I think we're going to move to the conference room. If you have additional questions, I'm happy to talk with you individually.
Today, so he's here all day long. So if y'all do have some questions that come up later, feel free to ask Jim. So again, we're going to be doing testing certifications in here. So if y'all want to see some equipment that you would test, we've got the 201 equipment and 101 equipment, gold certification equipment here. So yeah, he's available here all day long. So
Okay.
any last minute questions for Jim? Good.
Okay. Great.
Thank you, Jim.
Okay,
Appreciate it.
thank you. Thanks.
We've got Michelle and Andre. Yeah.
You guys want to take maybe like
we're not doing anything yet.
Yes, okay.
We've been
Just 'cause I
approached
know-
by some people,
Okay.
but
Because I
nothing.
know we chatted
Yeah.
maybe like a year or two ago.
Yeah.
And you know, what I love is to get that gold is because we're big advocates of you have to work on a machine, right? Like
Right.
you can't just say, okay, because we've had students come that are certified and they've never touched it. They don't know how to turn a machine on. Like
right.
so that hands-on portion of the gold standard is essential.
We've intention from the beginning. We tried to focus on areas where there wasn't an industry certification, but you know, at some point, I was talking to my board. Now maybe we should listen to our customer because people keep asking for it on CNC. Because you know, I used to be at NIMS, but I don't know what's happened there. But you know, I just leave it at that. I don't know what's happening there. But we've been
I'm
approached
just gonna walk around
by
you to
a number of folks, some other manufacturers as well, and you know, the problem is we have so much on our plate now with the existing stuff. So I'm not sure when that would happen.
My name is Mark Bensky. I'm Director of Technical Services. I've been with Tech Labs for 10 years. We interact with customers at every level, from installation to orientation to site prep, facility requirements, and I'm trying to think, we do so much. It's so hard to keep it all straight.
My name is Ross Patton. I'm our inside sales manager. My role is essentially to support our sales team while they're outside, but ultimately supporting our customers. Without the customer, there's no Tech Labs.
It's rewarding because you do see that you actually do make a difference. You're actually seeing students use the equipment and they're excited about it.
Customers love working with Tech Labs because of our support, our back-end support, our after the sale. We treat them like family. We're partners with them, and we like to create lifelong partnerships. We want to come back and sell other programs. We want to have other equipment in different labs, and so in order to do that, we've got to make sure that the first lab we sold was taken care of.
If we're only meeting your expectations, we're not doing our job right. We want to go above what you're expecting us to do and what you expect any other company to do.
The way we've been in business for 50 years now is not just making a sale and then leaving the school. We support them. We sometimes will go back. Third instructors, fourth instructors have turned over in that particular role, and we'll go back and try to retrain the new folks because we understand that the equipment we sell is not going to be a paperweight. It is there for training folks, and so we want to make sure that the new instructor knows how to use it. It's an ongoing process. They need support. They call us. We take care of them, and if we need to go back out on site for something, we will.
Everyone wants to see, what we do matter and make an impact.
We change futures and change lives is what I like to tell people.
You guys, I showered today, so you really don't have to go all the way to the back.
Nobody likes the front.
I know. God, am I that scary looking today?
About themselves, man.
I got a whole 8 hours of sleep and everything. All right, I feel better now. I was like, did I do something?
Well, perfect. Well, we'll go and get started. I know some other people coming in, but Michelle's here to talk about the LaVille CNC machine here. We also want to let you know we have a mixed group of education and commercial industry, so feel free to talk to people if you don't see them at school logos. They might be from commercial industry. It could be an opportunity to network there. I know a lot of the schools are always looking for industry partners, so feel free you can ask me about connecting people. We can do that as well.
Take pictures, please.
So, without further ado, we'll give it over to the LaVille folks and Michelle.
Thank you. Hi, everyone. As I said, my name is Michelle Leon. I'm the operations manager at Level Technology. This is Andres Leon. No coincidence there. We are a family company. He is our general manager and the lead engineer on all of our machines. We are a family business out of Orlando, Florida. I like to let you guys know that because I believe support and knowing where your products come from is really important. So if you ever have a question or need anything from us, we are a phone call away. You will get someone in Orlando that will actually answer a phone instead of having to press 1 and then 5 and then 8 and then do the hokey pokey and hope you get a human being. So, today, my goal to share with you is to talk a little bit about, I'm sure you've heard over and over and over, and possibly over again, the skills gap. We have a crisis going on. We have skilled laborers that are exiting the workforce, and we just don't have enough people interested in coming in and exploring manufacturing. And I'm sure, again, you've heard all of these things before. What's the problem? Well, one, the narrative, right? We've put manufacturing in this place. It's dark, it's dirty, it's dangerous. I don't want to do that, right? Computers are cool. I want to sit in a cushy office in a nice comfy chair, right? And I want to work on a computer. The other thing is, my generation, we were told, if you didn't go to a 4-year university and get a degree, I was less. We have come to know that that is the farthest thing from the truth, right? No one is less. I think the beauty of us as human beings is we all have a gift and we all have a purpose. And to try to put children into one box is a disservice to the children, right? We need to allow them to explore. I always tell Andres, if he were to have to work in a cubicle with a tie on, he would be the most miserable person in the world, right? He loves to be on the floor, pants full of grease, chips, it looks like glitter in his hair, right? Chips, and that is his happy place. Can you imagine if we put him in a box, right? And so I want to encourage everyone here, in whatever path that you're in, to help encourage children to explore different career paths and show them that no matter what they choose, where their heart takes them, they are never less. They are more, and we are better for it because somebody who's passionate about what they do, they do it well, and they excel, and they grow. And then you'll never work a day in your life. It's that thing, if you love what you do, right? So today I want to kind of show you how we can help students start exploring, in my world, a world of manufacturing from as early as middle school. What are the tools that we can offer them so that they can learn and touch and get started? And the beauty of the system that I want to share with you today is there's also this running joke that we want a student right out of school with 10 years experience, right? Like, people want experienced labor. We can't really do that in terms of work experience. But can you imagine if we started a child in middle school on a machine, learning something as simple as X, Y, and Z? I have an 8-year-old. She's starting to learn Cartesian coordinates. We're starting geometry. We're starting arithmetic and algebra. Well, when I was a kid, I was like, well, what good is that? Where am I going to use that? It's the question we all asked. Well, if we can show them how we can apply some of these mathematics in the real world and take something as simple as just a block of metal and show them how to turn it into something, how much more worthwhile is this skill to them now? Now it's not just X plus B equals Z. I made something. Creative. How do we take that student who's interested in tinkering and robotics, and now instead of them having to Amazon 20 different parts, let me just make the one that I need. Let's give them the skills to think, to challenge themselves. And so that can start, as, actually even earlier. I said I have an 8-year-old. My daughter plays with a robot. During COVID, funny enough, we took a robot home with us to work, one of these. And at the time, she was watching a show called PJ Masks, and they had a robot in pajamas. And my daughter literally took a pair of pajamas and put it on the robot at home and started having it move around and pick up parts and put them down. Like, we cannot underestimate what our kids can do. That is the worst problem, right? I love this, actually, this sound. I actually told him to run the machine. One of the things I love is Andres and any of the machinists at our shop, I call it the Spidey sense. He can hear all the way on the other end. If the machine makes the slightest change in pitch, he can run over and he'll stop it. Because when we learn by doing hands-on and touching and using, you develop skills that you'll never learn in a textbook. So having sounds and noises is very, very important, I think, when it comes to learning any of these skills. So we'll go back to middle school. We have a machine, it's called the Edu Mini Mill. And it sits probably about yay big, sits on a table. I'll show you a quick video about it. But it is your entry-level CNC machine. It's no coolant, no tool changer, but what are we teaching a student on here? We're teaching them how to think in 3 dimensions. We're teaching them how to use those math skills that they're utilizing and learning in school to create. We're getting their minds to think in a different way. And then on top of that, we're exposing them to a career option. You may be talking to the next doctor and she does this and it's nothing, but at least she knew it was there. But then maybe that doctor in the future will use things like this, as we've seen, to make blood filters. Titanium screws for hips, eye lenses and implants. So you never know when any skill that you learn or information that you learn today could be applied in the future, and how having that vast amount of knowledge can shape the way that you form your career. So I'm going to show you a little bit about the Edu Mini, so you have a little bit of a frame of reference. Very simple, very to the point, but that's all it needs to be, right? We've now exposed a child or a student to this kind of technology. Now imagine if we have 1, 2, or 3 of these in every middle school in your counties. Again, exposure, trying, building, creating. Now let's say this student moves on to high school. Well, now they have the basic skills that they probably would never have even touched until a technical school, right? Now we can go into a little bit more advanced machining. So this is our Edu Mill. This machine can do both additive and subtractive manufacturing all on one system. We can add a 3D printing head on it. We can print in plastics. We can print in metal. So we can 3D print a part in metal. We can sinter and harden it. And then we can put it back into the machine and we can CNC it to its final version. How incredible is this skill to industry that we now have somebody that can take a full product, prototyping, development, manufacturing from start to finish in such a complex way. There are parts that we can 3D print in metal that would take days to CNC. Well, we can now start that with this 3D printing system. On top of that, most metal 3D printing systems require you to send the part off and get sintered somewhere else. Well, what did the student learn there? How to print a FedEx label? That's not, we can teach that any day. But if I have the kiln in the school, let's say I put the piece in and it comes out as dust, that's a learning experience, right? What did I do wrong? Was the temperature too high? Did I not print it correctly? Did I not put enough carbon in there? Did I not leave it in long enough? Okay, let's do it again. All right, now this time I got it right, but it melted a little bit, or maybe I didn't put enough material. It's a learning experience. So having all those tools there for them to play and touch and experience is so essential. And so one of the nice things that we do as well is we create project kits. Because of course, you guys need to know where to start, right? So we have 3 simple project kits with the metal, and it goes from beginner, advanced, intermediate, and advanced, and it gives them a foundation and a starting point. How should this process really look and work? And then from there, we actually encourage students to make mistakes. Okay, now what happens? It worked well at 300. What happens if I make it 400? What happens if I make it 200? And let's learn how materials work, because I think a student that understands how a process works is more valuable than a student that just knows how to follow directions. Because who's gonna be your problem solver in industry? Not the guy that just knows how to follow A, B, and C. He's valuable. But the person that can figure out what happens when step B doesn't work, and how do I fix it to get to step C? And that's how these systems help. I'm also going to share how we can take this machine and we can also automate it. So now we can teach something like robotics and assembly all on one machine. It's very inspiring music too. I hope you're feeling it right now in this very moment. So this is our eDo mill with a automatic tool changer because we have the robot on it. But if we were to go the 3D printing route, it wouldn't have a tool changer, it'd have the 3D printing head added onto it. It is, yes. And we're actually, what he's cutting, and you're hearing the noise of, is we're cutting these business card holders right now as well. So again, now we had the opportunity to teach the basics. Now we took those basics the next step in high school. We've either taught them additive and subtractive manufacturing, we've added a robot, we've taught automation. We've grown, we've added a tool changer, we've added other things. We're making the puzzle more complex. But what's great is we can also still teach the basic. Let's say this student never had an opportunity to learn from here. It's not like those skills can't be taught. This machine can still teach basics. Now, the even more exciting part is now this student goes to your technical college, and now we can teach advanced manufacturing. These are the skills that the industry is really lacking right now. We can teach turning, we can teach milling, we can teach 4-axis, we have a 5-axis, we have a mill turn. Our 5-axis is a simultaneous 5-axis that takes up probably the footprint smaller than this guy right here. And we can automate these cells. We can make a complex machining system, which I'm actually going to show you a sneak peek. It got added to my slides just an hour ago of a system we actually did in partnership with APT at a school. It is a robot on a rail. You'll see it with a mill and a lathe all in combination. These are things that we're going to be exposed to out in the real world. So I'll show that to you briefly. Again, sneak peek, it's not completely done, no inspirational music, just but I did want you guys to get to see it. Our lathe, so you can see we're turning parts. We've got these industry robots, again, things that students are going to see in the field. And why is that important too? We talk about industry. What does industry see? Somebody once told me that the product of a school, if you think about we all make a product, our product is a machine. The product of the school is the student, right? And so it is our job as educators and as industry to create the best product possible for industry, who is our customer. And so to do that, we need to make sure students are prepared for what they're going to see in the real world. Such things like FANUC controls. Our machines come with industry standard FANUC controls, the exact same controls they'll see on larger machines. We partner, with FANUC again on their robots. So every skill that they're going to learn by touching these machines and utilizing them are things that they're actually going to use and transfer directly to any machine. I also think it's fun to say you made a giant chess piece and get to take it home. So that's always nice too. This is our mill, which is the machine that you see over here. So what makes our machines a little bit different? I'm going to have Andres go into the anatomy of those machines in just a moment, but I also want to talk about ease of use. A lot of people will tell me, well, they're going to see large machines in schools. Yeah, that's great, but is that realistic for a classroom setting? Most classrooms I see have about 20 students. If you had a room like this, you could maybe fit 1, 2 machines in there. The nice thing about our machines is we can pod these machines. We can put 4 machines potted up in maybe a center this big, and now we can put another 4 here. We have a school that has 12 machines at 6 mills and 6 lathes, and they're able to get multiple students up and touching and working, because one of the things we need them to do is feel and create and really explore. Watching somebody else cut apart, as we all know, kids have the attention span of a goldfish, right? That cell phone's gonna buzz, something's gonna happen, somebody's gonna talk about what's going on this weekend. So we want them engaged. And so that's one of the things I want you guys to explore and make note of, is the fact that this machine is compact and that's done with purpose. It can roll in and out of a standard doorway. So perhaps your machining lab needs it today and maybe your engineering program needs it tomorrow. We can roll it out over there. We just talked about creating parts maybe for a robotics team, a medical program. We can talk about prototyping. If you have an engineering program and you need to make tensile specimens for material hardness testing, we can make that. We talk about the 3D printing. Maybe they need to utilize that capability in another program. So keeping in mind its mobility, its flexibility, and the industry standard portions and those skills that they can transfer. Before I move on, does anybody have any questions for me? I know my voice is lovely, but you probably don't want to hear it straight through.
Can we see what you just pulled out?
Yeah, so he's gonna live cut for you guys as well, but it's the business card holder / cell phone holder that I was holding up earlier.
Is there a complementary curriculum package?
So,
Like when you said cart, search cart, is that a project or what is
so we offer project kits that can be purchased, and the project kit, like for the 3D printing, includes all of the parts and materials that you would need in order to go through that project. So one of the projects on the machine is actually this business card holder. So we'll give you all the parts, the pieces, I believe the program, and things that you would need to complete the project.
Is there, you're using a FANUC,
Yes.
for the CNC portion. Doesn't FANUC have curriculum available for their CNC portion?
Yes, so FANUC just rolled out, and the Tech Labs team will be able to give you more information on their curriculum, but they just rolled out an online CNC curriculum that I believe will feed into the NOCD certifications that are being worked on.
So then,
Yes.
when you mention project, are we talking a class project, a
Yes.
individual project?
So each student would do their own. So it's something that you would utilize as a classroom, but we encourage every student to do it themselves. And that's why I go back to, imagine if everybody's sharing one machine. How long would this project take? So we go back to allowing them that time on the machine to really get that hands-on experience. I'll give you an example. We take a lot of interns from a local manufacturing program. We had several of them come in and they didn't know what a caliper was, a micrometer. Like these are, and he graduated. And the instructor came in because his job is to come and check in on the interns. So proud. How's my star student doing? I was like, can we have an honest conversation? And he said yes. And he, you look, the look of dropped. I was like, this is not, he's a wonderful person. He's got the foundations. But how does a student graduate and not know the basic tools of the trade, right? So that's why we want them to make the part. We want them to make mistakes on the part. We want them to learn. We want them to know how to measure a tool. What are feeds and speeds? What are the different materials that they're going to be utilizing? And then we may think, oh, well, that's a lot of material. We can start on something like wax, or we were talking, about acrylic. There's other tools, and then maybe their final project is to make something in metal, so that they can learn how different materials react. But yeah, we want each student to be walking out with something that they can be proud of and something that they've made. And so that's what our projects. This is one of our projects to actually make this part.
I'm curious, do they write the code or does it teach them how to use software to write the code? the whole point is to understand how to set up tools, all tools, how to set up your part. If you have an automatic tool sensor, how to do that, get the G codes that run that. And then, so we have a project that is aligned with NIMS, and they're supposed to write the code by hand. Okay. So ideally, they write the code by hand, run it on the machines, and they can get a working part. If you're using CAD, you can do that as well. You can get a little bit more complex and do high-speed cuts, stuff like that. So, but the whole point is for them to go from here's a print, making a part. So they have to know all the steps for that. Now, some students might just do the programming side of things. Some students are just going to do the machining side of things. But they need to understand how both work. So they have to go through that.
I was curious, do you have a 3D printed part from it by chance?
We have a sample kit, and it is somewhere in this building, and so I didn't bring another one because I thought it was here. And so what it was nice about it, and we could show you examples, but basically we had a plastic 3D printed part, we had a metal, what we call a green part, and a sintered part, so you could see what they would look like freshly printed, and then once it's been hardened. We had a 5-axis part, which is actually a turbine. And so what I actually liked about the kit too is all of the parts in there are actually industry parts, because one of the things I want to always stress is this machine, although it is a teaching tool, it is a CNC machine. This is something that is used in industry. We actually have a sister company that makes aviation instruments. We use our machines all day, every day long, making parts for those instruments. So all of the parts in the kit, one is a servo cover, one is a plastic acrylic cover that firefighters use when they want to check the flow of water through a hose. And so it's a nice little representation of like what is the potential of the machines and what's the quality of the parts and the prints. If we can find it, we're going to move the machine later outside because we're going to keep cutting. And so if anybody has questions or anything like that, Andres is we're not done just yet. He's going to go over his part, but yes, that we'll hopefully be able to show you something. My pleasure.
So the project kit also, you can obviously modify it however you want, but it will come with like that thing's sheet code. Yeah. So the person will come with the kit saying, here's we've got this part done. Let's set up the machine or our part. Then they can use that. Yeah. So you'll get all the tooling, all the material, the device, the parallel sets, and then the G code. So, and you'll get it both in the.
Oh.
You'll get it'll be loaded on the machine if you order it with the machine, and you'll also get the file as well on the USB. So.
Any other questions so far before we get into machine anatomy? Yeah.
Is there a way to upgrade the memory? Yes. You can talk to your Tech Labs representative, and we can
Fanuc
work with
is
them
very
through that.
stingy with memory.
Yeah, I mean, my first year I had it. My kid did it. He's like, I had to break this into like multiple parts. Yes. I tried to like mouse the camera or something crazy. Yes, that. Why are you starting with the hardest thing possible? But that's what we ran into. Some lines of code. They have hardly any memory. Yeah. So what the control has an expansion board, and what you need to do is just get a high-speed Ethernet board that will have memory in there, and then it'll be probably like a 16 or 32 gig memory that you can use. So.
Any other questions so far? So I hope before we get into machine technicalities that you can kind of see the career path that we wish we would see more in education, because now the student that graduates from this advanced program has, the proverbial maybe 6 years of experience manufacturing than maybe had they just started here already at this technical college. And so that's way more valuable to them and to the industry and to the needs that we have than maybe just those basic skills that they would have learned at the beginning. The other thing that we have found is the student that you talk to in high school, for the most part, kind of knows where they want to go in their life, right? They may not know exactly what they want to be, but they found a path. But maybe they never knew this path was an option because there was never that exposure or that knowledge. You're nodding, and I'm assuming you've probably heard this before. but they don't know. You don't know what you don't know. And so if you don't get an opportunity to learn and to try, it's probably too late. And maybe they're going to end up in a career that, again, they didn't like or they weren't meant for. So this early exposure in middle schools and trying, I think, is so, so important, which may create a better funnel so that we have more students ending up here. So that's the end of my part. If anybody has any questions about this or the machine lineups or what we offer. No? Well, then I will pass it on to Andres, who will take away and just tell you a little bit about what our machine has, how it compares to industry, why it's important, and then he'll probably cut another demo part for you guys as well.
All right, so just to touch on what she was saying, and just the example of the kid that came in for an interview, and he graduated and he knew his stuff, but he didn't really have that much experience. It's something that I've noticed. We travel, visit schools, see their programs, and one that I liked seeing, but I also saw a little bit of a problem in the way they were doing it is. They have this school up in Canada where they are running, I think it's a 2-year or 2.5-year program to go from 0 to 5-axis. If you know CNC, you don't learn from 0 to 5-axis in 2.5 years. You don't learn it in 5 years. It takes a long time to be very good in 5-axis machining. So in my head, I remember this kid coming to, the shop and saying, hey, I just graduated, I know my stuff, I wanna work. I'm like, well, this kid had however long his program was, but he was lacking experience. Well, now you have this kid saying, hey, I know 5-axis. I graduated, I have my certificate. Well, you don't. You know the basics of it maybe, but you don't have the experience, which is where this comes into play. If you can grab the students and start them, younger, they'll have that 5-6 year, maybe 7 or 8, depending on how the county does their planning, where they will be an expert in their field. 3, 4, 5-axis mill turns, multi-axis machines. So that's what we would like to see. So I just wanted to touch on that. Now we're gonna go into our machines. All right. So you're probably used, if you know the world of CNC, you're used to big machines, a lot of power, a lot of torque.
You don't have an instructor that has the skill or the knowledge to teach these things. We offer workshops through all of our distributors. We actually just had a few with Tech Labs a few weeks ago, and so those are complementary to the instructors because again we are trying to help you reinforce and invigorate the workforce. So Matt does milling and turning, and then we host a few every year in partnership with FANUC on 5-axis as well. So those are opportunities and those are things that are available to you and to your schools to help implement these machines.
All right, so, big machines. Ours, not so big. So what's the difference? Why are we going small versus big? Well, one of the things is, why do you need a big machine in an educational environment? You need the power. You need to make big parts. You could if you wanted to, but are you going to? Not really. It's a waste of material. The material costs money, and you have to pay for it. And it takes a long time to machine big parts. So does a small machine make sense? Yeah, in that sense, yes. The next one is, big machines are powerful and, I want to cut all sorts of material. True. But again, you're teaching kids, you're teaching the basics. You're not teaching them how to cut titanium, Inconel, stuff like that. One, because it's very expensive. This piece of aluminum, $2, maybe $3, depending on where you buy it. This piece of titanium, $500. Are you gonna spend $500 on this for your student to maybe break up, mess it up? Not really. So, do we need the torque and, the big machine for that, to cut the exotic materials? No. Again, what you want is the student to learn the basics of CNC and work their way up to advanced machining. So a small machine kind of does make sense that way. We do offer with a FANUC control, which is an industry standard. They say, and I have no way to measure it, they say they have about 65% of the market worldwide. So wherever your students go in the world, they will see a final control. And then we use industry components, industry standard components. So our machines use linear guideways, ball screws. These are the same components that are used on big CNC machines. So there is no big difference in terms of technology that's in here. Our machines are just smaller. A nice thing about our machines also is that they fit through a standard doorway. So if your school does not have a big warehouse space with big, bay doors, and you want to start your CNC program, you're gonna have to either knock down some walls, some windows to put the machines in through, and make a whole thing around that machine versus, you buy 1 or 2 of ours, you roll them around. It's like, oh, we have like she said, we have a music at 2 o'clock. Let's roll the machines out, do your music class, and then, next day, roll the machines back in, do your CNC class, and stuff like that. So this is why our machines are small and why they make sense to have them in your programs. It's just it's the right tool for the right reason. Students, you put them in front of a giant machine, $500,000 machine, and they're just gonna be like, I don't want to touch that because I don't know how to use it. I don't want to break it.
It's intimidating. Large machines can be intimidating for students because, again, we talk about tools. A large machine takes a large tool. There's bigger noises, harder vibrations. Like, I feel, again, I have kids, like, this doesn't look as intimidating. It's more approachable, more visible.
I forgot what I was going to say. Oh, yes, I remember now. So also, large machines, they have a lot of power. If you crash them, it's going to be messy. I've seen machines that I actually saw a picture the other day where it was a horizontal machine, huge machine that has a tombstone that probably weighs about half a ton to a ton maybe. Big piece of metal. And the spindle just crammed into it and took it out of its base, and it was just hanging on the spindle, the whole tombstone. I don't think you want to see that in your, in your programs. This machine crashes, you'll probably break the tool, might disalign the spindle, maybe. Align it back up. It's actually very simple to do. And put a new tool in there. That's the worst that could happen. So our machines are designed with students in mind. So if they're going to crash it, which they will because they're learning, nothing is going to happen. It's not going to be costly for you guys. So now into what can they learn with this machine. This is one of our intermediate to advanced machines. Well, power requirements, yes. So all our machines are 220 volts single phase. However, we do have a step-down transformer, so you can plug it into 110. So you don't need to have special power requirements. Again, if you have your music room and you want to run this, you just bring it in, plug it into your wall, you're good to go. What students can learn from this. So we have,
We're a great team.
Yeah. We have, your basic 3-axis movements. We can do a 4th-axis system as well. We have automatic tool change that helps in efficiency when you're running a program. You have one tool to do holes, but then you want to use a different tool to do pockets, and then a third tool to do something else. In the past, machines were single tool. So you do your one operation, you stop the machine, you come in, you change it, you have to measure the new tool, put those coordinates in, and then have it run. Nowadays, everything's automated, so the machine will just drop off tool number 1, pick up tool number 2, and continue. So you can get that from our system. We can do probing. So if you want to do measure, you cut your part, and then you want to measure it, make sure everything looks good. You can put a probe in there, and then you run the cycles and get all the errors, and it'll say like, okay, there's supposed to be a hole here, but maybe the tap broke or the drill bit broke, and then it'll try to measure. And it's like, oh no, there's something there. This part is wrong. So now your students will know if they're running a production of 10, 20, 50 parts, and they're not measuring everything because, you know, maybe you have them running 3, 4 machines at a time. You know, it's something that industry might have you do. Then you don't have time to measure everything. So you grab your part, you come over here and be like, oh, there's an error there. So this part is wrong, it's bad. So it's crap. Put the next one in, have it run, you know, fix whatever the error was, and have it run again, and then continue. So they can learn that. We can do rigid tapping on this machine. We can do, let me see, we have coolant capabilities, air blast, and then also we have the robotics capability. If you want your program to have advanced automation, you know, you can put the yellow robot, you can put the white robot, and then just have them run at the same time, or you can have them run independently of each other. You know, you run your robotics class on one side, CNC on the other, and then once the students get both, then you have them do the automation, how to communicate with the machine and the robot, and how to make them handshake so the robot doesn't just go in there when the machine is running, or the machine doesn't start moving when the robot is in there replacing a part. You know, things like that.
Can you, because this is not an automated door, can you upgrade that to?
Yes.
It's just an addition to?
Mm-hmm. Yeah, so we would automate, not the front door, we would automate the side door. That's how we have a, I don't know if we have a picture of it. No, we don't have a picture of it. Yeah, so yeah, it would be an automated side door. I mean, you can make it so it opens the door and then loads it from the front, but we have a...
Video that you saw, it has it with a robot. That door opens like the one in the video opens like a door like this, not like this. So the robot actually grabs the handle and opens it. So we can do that too instead of making it automatic. So we have a couple different robotic integration options depending on what you already have in the field and things like that.
So we have those systems, but if you want a little bit more advanced, then we can partner with APT to do that whole dual machine, robot on the rail, and stuff like that. Or if you have a vision, because that system actually was a vision from the college. They said, this is what I'm thinking. I want a robot on a rail. I want them one machine here, one machine there. And the way it goes is they actually sat down. It was Ricardo, the guys from the college, and the distributor. They sat down at I think it was in the college, and instead of drawing it on a napkin. That's how the whole concept came about. And then from there, it went to actual engineering drawings, and then from there, it went to the physical system. So if you have a vision, you know, we can work with you and make what you want. So
Even the College of the Canyons, I talked about potting the machines. So that kind of vision came from them. They had a space and they wanted to figure out how do we get the most machines. Again, they have 12 machines in that space. So imagine that machine like backed up to each other, and then we backed up another four. So we just made like a circle. And in between each junction, they put a toolbox. So every machine has its own toolbox, and then they ran all of like the hoses and power from the top, and it looks beautiful. There's photos of it as well, but just we can get creative. Like if you have a space that you're trying to work within, I mean, we're always available. The Tech Labs team is incredible. We're happy to sit down and figure out what is the best solution for you, your program, and your space.
What is the envelope? It's larger than that, right?
envelope 4?
Like, you can't go side by side, can you?
On the machines, you could, but we do like having some space to, you know, get around in case you need to troubleshoot something. Like if you put them side by side, then
I thought it had a piece on the back that went beyond the cart.
this one.
No, this is the whole. That's the whole machine.
So no, there's a little part that hangs, but so the way they potted them is they're not right next to each other. There's a little space in between for, you know, that, but also for all the wiring that came in through the roof. So, but overall, I would say the whole system is, you know, from where the wall is to maybe about right here, and then you have 1, 2, 3, 4 machines. Any other questions?
What kind of maintenance is needed for them?
So it's depending on the use. On a school, you know, it doesn't get used as often as in industry. So once a week, what I like to tell everyone is like once a week, give it a good cleanup, maintain the guideways and the ball screws oiled. If you're not going to use them for a while, then just put grease to cover them, so to keep them from rusting. And that's about it. They're very low maintenance, really.
We also offer in-person training as well. So if you want doing that workshop, which is kind of open to everybody. If you want like one-on-one with your instructor, whoever's going to be working with the machines, we have Carlos, he does an excellent, it's either a full day on milling or a full day on turning, or we could do a 2-day. And that's our whole goal, is to get that instructor comfortable and confident in the machine, how it works, and how to get their program started. So although we don't do curriculum, we'll make sure that they feel confident in the machine and be able to work with their students.
All right. I think that's it for me. Like,
Do you want to have them, I don't know if anybody wants to come up, he's going to start apart so he can show you how
yeah, if you have any questions about it, see it
and that's
running.
kind of the nice thing about the machines. We have lots of windows on them. Our EDU actually has windows on all sides, but this one has 2 windows. You guys are welcome to come on up. And then kind of see how it cuts, how the tool changer works, and yeah, we'll cut apart for anybody
Start
that's
apart.
interested in asking any questions.
All right.
Yeah, please, like, don't be shy. Andres showered also this morning.
Okay, that was Monday. Alistair Monday. Guess where Alistair wanted to go Tuesday?
You did.
I'm trying to get more people to I'm like this. So I got them releasing the live welder stuff on there. I got some new moves that way. Maybe should I go above? Straight above? Move it here, just go straight down. I'll give it 10-15 minutes so we can at least see this, so you kind of see the setup and everything else, so you kind of see what's going on. Do you have everything you need? Are you good? Is there anything you're missing?
For the most part, the only thing that I have not had a chance to actually preview is the Stratasys stuff. Which, I don't know, he said everything is all separate. It's not like one slide to roll through, so like, I'll do what I can.
So I'm thinking, can you do that overlay on the timer? If I move that camera just a random spot in the warehouse, can you kind of get a wide view?
I'm saving a 30-minute clip of all of our YouTube videos right now, but I also have a 30-minute timer.
Okay. If you want, like that, we can live stream. I can put that near the door and just kind of have the whole warehouse as a background.
Let's see.
Did you meet him before?
No, I'll come back, Greg. I'm going to do check-ins. Wait, let y'all know. We got about 30 minutes. He's wrapping up barbecues, so you can wrap up barbecues. You'll have 30 minutes. Y'all feel free to go anywhere you want to go. You got equipment everywhere. You were going to stage out, so you're not attached. You can feel free to roam around and do your thing. 115.
Okay, thank you.
You okay?
Just hiding in my corner.
real basic. This is like middle school, high school level. Okay. Our basic, we'll say, foundation training. So you have to teach them autonomous driving license. What does it put in like C? Yeah. Basics, right. Bicycles, that kind of stuff, this is great. This is a driver here. So this is so this one actually is GPS. So a lot of your farming now is able to cross it off. Yeah. But this actually has a sprayer that goes on here, attachment. So let's say this is your field. You can program this thing to yeah.
Pretty sure it maxes out at 30. That's what they used to tell us when we first started doing this.
Can you tell me about the curriculum as well?
That's what I do. I try to do anyway.
Well, there's a cloud-based training curriculum. If you could be working on well, I was just going through literally step one. So don't forget your stuff here, and I will get your card at some point. Any questions? Yeah, he's a CG card. Cool. Gary. Perfect. No, Brian. Brian. Okay. Brian here. So what is she?
Oh, I got it. I'll still home. Yeah.
Yeah, but there are the outliers that want to do this. But you know, generally it's what's the minimum that is required? That's how I got my doctorate. Right. How are you?
Good, how are you?
Great.
I'm Becca with Coterra.
Chris McKay.
Nice to meet
What do you do there?
External Affairs.
What is
We're an
Coterra
oil and
about?
gas company.
Okay. All right. Cool.
Headquarters are here, but I cover the Permian Basin.
Oh,
West Texas.
nice.
So we have a
Okay.
lot of.
Out there where Stonehenge is?
Yeah. In Odessa.
Uh-huh.
UTPB.
Seen it. Yeah. That's pretty cool.
Better than the real one.
Uh-huh.
Yeah, it's a good area. We have a lot of schools out there that are trying to build out CTE labs for their strategy. They need to figure out what equipment, learning labs goes into that.
No, but I mean, who's building? Yeah. Have you met Eric? Oh, perfect. He could help. I think that's the thing is, yeah, I was just talking to superintendent, former superintendent here in Katy, been there forever, probably the biggest challenge we have is the inability to have that consultative discussion, because, we're really not, like I told him, I said, if somebody refers to me as a vendor, I'm not doing my job. Because I'm not here to sell you something.
Yep.
I'm here to teach you.
Yes.
Explain,
Yes.
listen,
Match up your needs if we
space,
can.
budget, goals, outcomes, and then it's a matter of, providing information they need in a proper, like we want to help you build implement a program with outcomes that are predictable by grade level.
Yes. Not
Right?
just drop off at
We
the
can do
sheet.
that, right? And it's like, we're here to service for life, if you'll give us a chance.
We're excited to work together.
Yeah. Did you?
This is Kristen.
Oh,
Hey. Kristen Barley with the
Kristen,
Nice to meet you.
nice to meet you.
With the Energy Education Foundation. So you
Sorry.
came
Are
and
you still?
presented. I was not on the rotation. So I wanted to squeeze the whole session in. I know. I was like, squeeze everybody in. So I'm more interested in your kind of education and your STEM activities.
You are interested in that?
We're redoing our mobile learning energy unit. So yeah, I was delving a little bit into your website, but.
So, what age group are we talking about?
Our learning units focus on middle school. I know you guys do K through 12, but we have these learning units that go out to the community now. They're old and outdated and everything else. So we have a company that's
out there in Odessa also?
we have been before, so we're up in Pennsylvania, Ohio, West Virginia. We've been in Louisiana. We've been out in California in the past.
Okay. But
And
y'all
we're based
are.
here. We're based here.
Got it, okay. But you're.
Unmute there. Choo choo choo. So you're okay. And I'll check the other one too.
Is the one out there?
Yeah. So this is for the live stream. Yep. So what you can do, Eric? So we would turn this up. You've got the remote, huh?
No, it's the speaker. The speaker's on.
See, Eric, test it, test it, test it, test it.
I need to exactly like I need to.
Somebody turned it off. Can you reach up and?
I'm Warner Brown. I'm the CEO and president of Tech Labs at XCal, and I'm the vice president of our other company, Tech Solutions. My parents started Tech Labs at XCal in the late 70s. I've been at Tech Labs at XCal for about 18 years, and the purchase of the companies from my parents started 5 years ago. We're extremely focused on how we treat people, even within our own company. That's why we've got people who've been here 30 plus, almost 40 years. You don't have people stay. You don't have long-standing relationships with your team members or even customers if you don't treat people how you.
Bronies is still live right now.
Okay.
So that's where the camera is.
Oh.
Transition is right there. That tape.
Gotcha.
Thank you for the opportunity to have here today and have folks come in and see the things that can help students and noise down the road. We pray you bless this time as we have this food, blessing to our bodies, give everyone a safe travel home, something safe travel back here tomorrow. You know, looking for round two. Thank you for this time. I pray you be honored and glorified. Thank you for prayer. Go ahead and eat, and I'll be announcing the things how we eat your moment.
I know. Grab a spot. There's waters and iced tea. Water's in these coolers. Eric, you still got the mic? Come to look at me where the coolers are.
Water says to meet where the coolers are.
There's water.
Oh, there's waters in there. Okay, gotcha. Yes, bottled waters in the cooler. There's iced tea.
The spot is the funniest guy at this company.
Should we play a little tables here?
It's tough. It's tough, man.
Spread out networks, like you said earlier, where people from schools, people from get to know one another.
We prayed for you, don't worry. You're welcome.
Hey, team leader.
Yay.
Grant, like, who? Yeah, he was helping with the chair.
I'm Warner Brown. I'm the CEO and president of Tech Labs at XCal, and I'm the vice president of our other company, Tech Solutions. My parents started Tech Labs at XCal in the late 70s. I've been at Tech Labs at XCal for about 18 years, and the purchase of the companies from my parents starting 5 years ago. We're extremely focused on how we treat people, even within our own company. That's why we've got people who've been here 30 plus, almost 40 years. You don't have people stay. You don't have long-standing relationships with your team members or even customers if you don't treat people how you want to be treated. For us, with Tech Labs and XCal, the people that work here and stay here, I really do enjoy seeing the change and impact that we do deliver. I literally can walk through buildings and see the change that somebody gets to experience in their life because they got nationally recognized credentials, or somebody was able to have a successful surgery or a heart replacement, and that was enabled by 3D printing. You know, those are things that are a lot more valuable to our team, and I think that's why a lot of us work here. We're a distributor for 27 different companies in 8 states. We are heavily focused on education. However, we are really invested in commercial and industrial markets. Our solutions enable us to walk into a room with a plant manager and be able to look at the outcomes that they need per shift or per skill set, per maintenance area, and help them deliver that because we're providing competency-based solution. So if you're in workforce development and you're trying to create a customized training plan for a company that doesn't want to do their own internal training, we can help deliver those solutions as well, specific to the number of hours, numbers of skills, and the targeted outcomes that that company or partner need. We're coming up on the 5th year anniversary of moving into our Solution Center here in Katy, Texas. And we just opened our Solution Center in Utah for XCal. And then XCal has its second Solution Center coming up to be open in the Denver metro area. The reason why we launched the Solution Center concept is we wanted to be able to better serve our customers by offering a facility where they could come and see a tailored solution for their visit in person in a way that fits their schedule. We also have sprinter vans that we load up with equipment, so even if you can't come to us, we're going to come to you. Many of our partners have worked very hard to develop nationally recognized credentials. SACA, the Smart Automation and Certification Alliance, the MSSC, Manufacturing Skills Standard Council, and then Stratasys and Fanuc are also partnered with NOCTI as well, which is a major nationally recognized credentialing body. Because the people that we represent are partnered with industry leaders, if we provide a solution to a school or to a company, the outcome is going to be a specific skill set that's competency-based, verifiable, and transferable into the workforce. Adopting technical solutions, whether they're for 3D printing, additive manufacturing, industrial automation or robotics, industrial maintenance, Industry 4.0, medical solutions, as well as welding. If it's something you don't understand, it can be very complicated and overwhelming. One of the things that we are able to deliver to our customers is the support of our subject matter experts. We have people that are certified, credentialed in these areas, as well as our manufacturers can help show and outline through a sequence how our equipment could be used without it being so intimidating, where it's not a program of study that you currently have, where we can come in and help you and your team understand the curriculum, the e-learning that supports that curriculum, the instructor materials, the training that comes with our solutions, and all of these things help with adoption and rollout and implementation. We're going to be there with you through the entire process. So yes, these are complicated solutions. They've been tailored and designed for educational use that ends and delivers with success in a program in a classroom. Our entire country, the United States of America, has a major skills gap problem. Our solutions are tailored to help government, companies, schools, and states work together to close the skills gap. We look forward to the opportunity to speak with you and learn more about what you're doing, no matter where you are in the development of your program or process. Reach out to us and we'll be happy to help.
My name is Clayton Webb. I'm an equipment technician here. This is University of Texas at Arlington Research Institute. I run the prototyping lab as well as help the researchers and interns with anything they need. 3D printing plays a pretty big part here in the research that goes on here at UTARI. So we've had Stratasys printers here from Tech Labs for approximately 2 years. We had the Neo 450S as the first. It's an SLA printer. And then we just recently got the G35, which is PolyJet.
My name is Alex Jamison. I'm a research scientist here in the Biomedical Technologies Division. Particularly, we focus on rehabilitation and preventative care. So some of the things that we make are soft robotic exoskeletons for the upper body. So we're creating basically a wearable that you can put on your hand or your wrist, and they're made out of silicone material, and they can inflate to apply motion to the joints. So this is to help people who have neurological conditions regain their function of their hand. We design everything in 3D modeling software. We do a lot of simulation work, and then once that's verified, then we need that exact geometry that we design to be part of the molds. So when we fabricate it, it's like an exact replica of what we're simulating. that's what we use the 3D printers for. Another option, I guess, would be to do like machining. We can use a CNC to make the molds out of metal. But then once we knew that 3D printers existed, we were like, why would we waste our time doing that when we could just do something that's a lot easier to customize and just make like that.
The researcher will generally send me a part file. I'll slice it within 10 minutes and be done and send to the printer and have it start printing. And with the SLA technology, it's really, really accurate. We literally take them out, clean them, cure them, and they're good to go.
We use resin 3D printers to create all of our molds just for prototyping in the lab. When it comes to actually making the parts, you never know what kind of issues you're going to run into, especially with the molds. There's a lot of trial and error. That's also the issue with if we did use a CNC to machine those parts, that takes up so much more time to like go back and fix an error, where 3D printing is a lot more flexible. The printing time was a huge factor for us because one mold that we would print on our previous printer could take up to like 2 to 3 days to print. And then on the Neo, it would take maybe like half a day. I know Clayton will just completely fill the tray and everything will come out fine. One of the reasons we got the Neo was because you can use different types of material in it. You never know when a new project pops up and then we need to try out something different. So I like that we have the option to do that.
So Tech Labs has been very good about responding to any issues we've had. They're very responsive at contacting the vendors and making things right.
My name is Mark Bensky. I'm Director of Technical Services. And I've been with Tech Labs for 10 years. We interact with customers at every level, from installation to orientation to site prep, facility requirements, and I'm trying to think, we do so much. It's so hard to keep it all straight.
My name is Ross Patton. I'm our inside sales manager. My role is essentially to support our sales team while they're outside, but ultimately supporting our customers. Without the customer, there's no Tech Labs.
It's rewarding because you do see that you actually do make a difference. You're actually seeing students use the equipment and they're excited about it.
Customers love working with Tech Labs because of our support, our back-end support, our after the sale. We treat them like family. We're partners with them, and we like to create lifelong partnerships. We want to come back and sell other programs. We want to have other equipment in different labs, and so in order to do that, we've got to make sure that the first lab we sold was taken care of.
If we're only meeting your expectations, we're not doing our job right. We want to go above what you're expecting us to do and what you expect any other company to do.
The way we've been in business for 50 years now is not just making a sale and then leaving the school. We support them. We sometimes will go back. Third instructors, fourth instructors have turned over in that particular role, and we'll go back and try to retrain the new folks because we understand that the equipment we sell is not going to be a paperweight. It is there for training folks, and so we want to make sure that the new instructor knows how to use it. It's an ongoing process. They need support. They call us. We take care of them, and if we need to go back out on site for something, we will.
Everyone wants to see, what we do matter and make an impact.
We change futures and change lives is what I like to tell people.
My name's Daniel Newland. I'm the field service manager for Tech Labs. I've been working here about 9 years. Really, a lot of what we do is helping customers, supporting them with existing products, as well as whenever you purchase something new from us, we offer installation services. So
Lunch learned,
So we can turn the lights down and get the music going if we need to. So don't fall asleep now that you got belly full. Stay away from the presentations. We're going to give it over here to Anthony from APT.
Yep. All
There
right.
you go, sir.
Thank
can,
you. Just put it anywhere?
Yeah, just like that would be good.
All right.
The black part is kind of where your hand is right now. So.
Okay. Should be good. All right. Uh-oh. That's all right.
It's funny, everything works up until
Right till you, yep, every time. That should be good. All right. Let me know when. Are we good? All right. All right, ladies and gentlemen, I want to say, first of all, I want to thank Tech Labs and XCal for inviting us out today. I'm very excited to share with you the ILS. My name is Anthony Thomas. I'm the Curriculum Director at APT Manufacturing Systems. We're from Hicksville, Ohio. We are a robotics integrator who partner with Fanuc Robots, which is really awesome. And we're just kind of getting started to get into the education realm. Two of our great products that we have is a mechatronics cart and a CSM. The CSM is what you're seeing here. So basically it's a full manufacturing assembly line setup where we start off with a CNC robo. And we have our different op stations that are going to take that piece and move it down a conveyor, and then it continues on to get laser etching, where it then gets picked up and set into a box, and then we have a small palletizer at the end of that. That's a really massive system. And when we're looking at tech schools who are now bringing in freshmen who maybe have very little experience or have any experience at all with robots, probably the last thing you want to do is throw them on a very expensive system and say, let's go learn how to work on robots. It's a very fast way to kill a system. We know that students make mistakes. That's what they do. So how do we get our students ready to work on a system as complex as a CSM or mechatronics cart? This is where the ILS is born. The other part, we know that there's a lot of trainers that are out there. And they're incredibly great trainers that are being used by schools all over the United States and all over the world. But one thing that we kept hearing back from our educators that we're partnering with is that they want to see more real-world components. To give you my background story here, I'm actually a high school science teacher. I'm new to this. My background's in curriculum and instruction. That's what my master's was in. Not this at all. Okay, I taught earth science, I taught physical science. That was my skill set. So when I was brought in to help write curriculum for APT, we had to start somewhere, and that's why I found this card. The one thing I liked about this that caught my eye coming into it was the same thing I asked out of my science classroom. I need real-world tools with real-world materials. That's what the ILS brings. And so that's what I want to show you here. I got a short slideshow to go through, and then we'll get right into the nitty-gritty. So the one thing that's a major advantage with the ILS cart is that you have one cart. With a lot of other trainers, they have an entire electronics cart, an entire pneumatics cart, an entire motor controls cart. So if you're a school or you're an industry, you're looking at training your employees, you got to have one of each of these really large carts, and you got to find somewhere to store these. Some schools are buying up to 10 of these carts at a time. You got to find a place to store all that. We have one cart with a lot of modules. So now this is the only thing you got to find storage for. And I can teach everything you need to know about relays on this one single module. And that just hangs on a French cleat on the back of the wall. Easy on, easy off. Makes that super easy for your students. You could fit up to 12 individual modules on here. However, I think what most instructors are going to find is that you don't want all 12. Your students are going to get lost in the weeds, right? They get too much distractions going on. They're going to get lost in all of that. So now we can pare this down to exactly the modules that we're working on, and it allows the students to start seeing the forest through the trees. It simplifies that learning so they can focus on those real-world skills without getting lost in all of the static and confusion in the background. The other part about the ILS that's handy is it comes with a fully stocked tool drawer, including the 87.5 fluke meter. This is every single thing that you need to operate with the ILS comes in this drawer. So you get your fluke meter, wire strippers, crimpers, and 3 terminal screwdrivers. We also have a T-wrench that is sometimes needed. For example, if I wanted to move our gear motor here, those are held in with hex bolts. So this is what that's in there for. So again, you don't have to go searching for tools. They're all stored right here. And then we have extra storage as well. We have a couple drawers down here that we'll go over here in just a minute. The next thing that I like about this is a lot of schools are like, okay, well, especially if I'm bringing in a robot, we got to worry about power supply. Am I going to have enough power? What type of power do I need? The entire cart runs on a single 110 extension cord. And from there, everything else is now, on the back side of this, we have power supplies that are converting that to 24-volt DC. And that's really important here because that allows us then to work in a safe environment. So while we want to teach students electrical safety, and that means disconnecting power, we understand that students are going to make mistakes. At least this way, at 24-volt DC, it's not going to be a costly mistake. All right, so we can have that here. So you can still practice all that safety. At the same time, we're working in a very safe environment for your students. The other reason why we talk about 24-volt DC is because when we look at electrical panels in industry, many of those components are running on 24-volt DC. And this is exactly what students are going to see when they enter an industrial workforce. So we're not trying to mimic the real world. We are doing the real world. When you look at these panels, each of these modules, these are real world components that are sitting in electrical panels in almost every single factory around the United States. So when your students come in and start working on these systems, they're going to understand what these actually mean and how to wire directly to those components. Again, wiring directly to them. You'll notice that nowhere on here do we have the plug-and-play style. Your students actually have to strip wires. They got to ferrule their wires. They may have to put ring terminals on there, right? So we are training your students how to do that so that when they enter the workforce, they're not coming in simply as an operator, but now they're coming in at a technician level. And they're able to problem solve and troubleshoot and work on these real world components. While it's hidden down here, this little push button box, that comes completely unwired. It's a blank box. One of the other parts I like about this curriculum and the ILS in general with all of its modules is that it is whatever you need it to be when you need it to be that. So in a lot of cases, you'll have different trainers that are, the students are building up a machine. They're building a machine. But now, if I want to go beyond that machine, well, that's not really what that was built for. This allows you to have full autonomy and really creativity on how you want to do that. So while we have our labs that are developed, you can go beyond those. You can totally go off on a tangent, and you're not going to hurt anything. It's, again, dream it and you can make it. That's what we're also teaching your students. It's really an amazing system to work with, okay? So like I said, we have a lot of different modules that are out there. Starting off, we have our electrical modules, such as the push button box and the relay. But we also have emergency devices. So we have an ESOP module that comes with an emergency controller. We've also just recently released several safety devices. So we have light curtain module, we have an area scanner module, and we also have an interlock, so a door interlock module. The door interlock module was just released 2 weeks ago. And I'll admit, it's a pretty cool system. Really neat stuff you can do there. We also have our PLC. So in this case, this is a compact Logix, but we also have a guard Logix that's available, as well as an HMI. So for those of you guys that have been in this for a while, right, remember, I'm kind of new to this, but if you've been in this for a while, you can start understanding, okay, if I just take, maybe if I took 4 of these guys together, I can really start to create a pretty cool system for my students. We also understand that colleges and tech schools aren't necessarily teaching courses that are just, this is all you're doing, right? It's this one tiny concept. You're doing pieces of these as you go. These will also mature with you. Because they're coming in blank, so to speak, those will mature with your students. As you get to more advanced topics and more advanced skills, it's the same components, but now we're doing more advanced things with those. This will mature with you. So now you don't have to go out and buy a whole nother module. I do want to mention on here the VFD and contactor overload modules. Again, we're constantly coming out with new modules all the time. This one was just released in March. It's our contactor overload. Allows you to do multiple things. So you can see we can go with a single motor control system with my breaker, motor starter, and an overload. And that ties into either our 3-phase motor that we have here that can be bought as an accessory, or the swivel link conveyor that can also be bought as an accessory. So you can control all that through there. If your school has their own 3-phase motor, you can run that as well, right? You're not tied to just that device. But again, I can look at this as a student and see this is a very simple system, right? But it's only going to go forward. Now we switch over to forward and reverse all on the same board. And now I have my motor starter protector. The beauty of this is that your students are going to learn not only how to wire the system with a breaker and an overload, but also the motor starter protector, and to understand those advantages and disadvantages of each. So they're looking at it in multiple ways. Again, we're trying to give those real-world components. So again, when we talk about the difference between just plug and play and your students actually having to wire these systems, right? When we look at our terminals up here, most of these are going to be spring terminals. Well, now you get to have that conversation about why are we using screw terminals here? Why is that really important when we start talking about 3-phase motors, right? Probably don't want to move those as much. So those are the types of things that you get to, those conversations that go a long way. Now, like I said, this is all about getting a roadmap to the CSM or the mechatronics cart. Why do we use these components? Why do we have this specific PowerFlex VFD? Why aren't we using something else? Why aren't we using a Siemens PLC? Why are we using a Compact Logix? The reason behind all of that is the ILS is the stepping stone to the mechatronics and the CSM. Every component that is on those two systems is sitting here within these modules. So if I'm teaching in a tech school or a community college or a four-year university, this is geared toward that freshman, sophomore entry level. You're going to get them introduced to all those components, including our pneumatics. Because it's going to be a whole lot easier to teach students how pneumatics works here in isolation than to show them how it works within that very compact space that we have within the mechatronics cart or our CSM. That again, that's the power of this system. And feel free to interrupt at any time with questions you might have. So then we talked about storage before, and we said, yes, there's more. Of course, there's always more, correct? All right, so we have our storage cart that's available. That's one way to do it. We also have a wall mount system. So as a school, you might only need one or two of the bases, but you could still buy multiple modules and then have a very small space to store that. So you don't need a large storage environment for this equipment. One other thing that I think is a major selling point, the base is huge, but then we have our small desktop model here. It does exactly the same thing. And one of the things I haven't mentioned yet is how this is all wired up and plumbed. So what you see is on each one of these panels, you kind of see it here, is we have our 24-volt DC ILMI connector. We have a 5 amp breaker switch, so you can easily turn on and off those without having to unplug them all the time. And then we also have air supply here. The base comes with an air compressor that's located underneath the top right here. This does not come with its own air supply. So the school will need to find a way to provide an air supply. But once you have that done, you can then run any module that's on here, you can run on the desktop model as well. Okay, the other neat thing about storage is this will fold down. And now the next one will sit right on top of that. You'll see this gap that we have here. That gap is actually done on purpose. That's our engineers being incredibly awesome people that they are. It's designed so when you put the next one on top, it's not going to hit any of this. So you can stack those up. And that way you don't need a lot of room, right? So just basically have a countertop filled with those. And you can put this at any angle that's comfortable for your students. Okay. All right. Are there any questions? Feel free to ask. All right. Oh. So as we were designing the curriculum, one of the things I decided is understanding who our students are and knowing that they're the hands-on learners. These are the students that are going home and tinkering every night, whether it's on their vehicle or taking part. I make fun of them always taking part of the toaster, trying to figure that out, right? They're taking things apart and putting them back together. It's one of those skills that I wish I had developed early, and I did not. So we wanted to design our labs for those students in mind. So it's hands-on, and it's reflective. The one thing that I know all of us have done as adults when we're sitting in trainings is we click through the slideshow as fast as we can, right? That's what we're trying to do, just get through that. And it's all, and we get to the end, we just take that 5-question multiple choice test. Yay, I got my certification. That's not what education is. We want our students to actually know what we need them to know. We need them to know these skills. We need them to know it inside and out. So that's done through reflective questions. So we look at our content. Each of our content is written with, again, we talk about those real world skills. It's hands-on and it's reflective. What went wrong as you were wiring this circuit? Did it work? Did it not work? Okay, if it didn't work, why did it not work? So they're all open-ended questions. The other part is making learning accessible. That doesn't mean like literally accessing the learning or the information, it's actually making it available so the students can understand it. So the way that our labs are written, they're written in a student-friendly language, so we're not going to bore them to death and drown them in technical jargon. The language is there, the vernacular is there when needed, but we're not trying to purposely make it inaccessible. We want to make sure that our students are learning these content as they go. So when we look at that, one of the things that we also do, and this is just an example here, but we try to provide background information. So on our Intro to Relays lab, it walks them through how a relay works, and then it walks through each of the types of relays that's on our relay module, and how each one of those behaves differently than the other relays. That's what we mean by making learning accessible. So as your students are reading through the labs, it gives them an opportunity to understand what's going on. Again, we go back to real-world skills. I'm going to show another example of this. Sorry for our folks at home. We also give students the schematics in real-world format. So while it might not be that 11 by 17 book set that we're used to seeing schematics in, it is the same exact design. If you bought an APT mechatronics cart and you asked for the schematics for that cart, this is exactly what those schematics are going to look like. So your students are going to see real-world schematics, and the early labs walk them through how to interpret those schematics step by step. As we continue on, it becomes less and less direct. And so then we get to like, okay, here's the schematic, go wire this up. Let's talk about our questions now. All right. So I know we're also in the day and age of, we want to know about our certifications. We want to know about what type of certifications. We are aligned with SACA and NACTI, as well as, and we have this here, so if you guys want to go ahead and scan that, you're more than welcome to. We have a page on our website that shows you all the certifications that all of our equipment will earn your students. All right. This is just an example of what labs we have. This is not all inclusive, so I'm sure that's hard to read all the way in the back of the room. But in terms of the layout of our labs, we have our wiring fundamentals and then relays. We have PLC programming, motor controls, we've got pneumatics, it's all there. When your school or organization buys our equipment, it will come, sorry, and kind of cut us off here. On our newly developed LMS. So this is a learning management system that we developed in-house in just the last year. We've now rolled this out with at least 12 different schools since October 1st. So yeah, this is going well. This is going very well. So we have a lot of schools on board. And I'm going to log in real quick here. And now what you guys can see here is we have our different modules. And these are all the different modules that are available. I'm going to go ahead and put that into table format. Maybe. Come on. So I get for not having a mouse. Oh, come on. Back. Oh, you're killing me. Well, maybe that was not the best option. Guess probably would have been better to leave it there. But we do have a lot of different labs that are available on here. Like I said, feel free to interrupt at any time if you have questions about what any of these labs are. I do want to mention right now, you'll notice that we have some, what we call the ICC. This is one of our top selling products. We did not bring it to this particular show, but this is the PLC and HMI that's on our mechatronics cart. as well as on our CSMs. And so we decided to also add these in here. Now the labs that we're doing for PLC programming within the ICC are the same labs that we're doing on the Compact Logics. The reason why they're different is they're not the same PLC. So for first-time PLC users, understanding how to address to certain ports within the PLC, when you got a totally different PLC, that's going to throw them off. So we decided to actually have those as two separate labs. So the instructions are tailored to that particular product. Now again, think about what we can do with this and what your students can do. So we think about the HMI. Again, this is something that we just released in July. So with this here, we decided to have students build a drink filling station. And that's what we have going on up here. And so your students start off with just learning how to put a button on an HMI and getting the motor to start. That's like, woo, right? It's like, yay, you push the button, minute go, okay? But then we go over all the different ways that you can create buttons. And then we have them start thinking about how would you design a drink filling station? And how would you adjust that if you had a 20 ounce, 32 ounce, or 64 ounce cup that you had to fill? So now we're talking about timers, we're talking about counters, and you're keeping track of all that information. So now, all I can do, what I've basically built this up to, is now you can select this. But now to get here, this is the 7th lab in the sequence. So your students have slowly accumulated all of this knowledge we were building on. Each lab builds onto the lab before it. So before we even got here, we've talked about numerical inputs. We've talked about list box selectors before we even got to this finalized state. And then we have that discussion with students about why. Why would we not want to use a numerical input for this? What are those, the downside to doing that? Why would I not want to use a list box selector? Why is this the best option? Are there better options that are out there? These are the things that our labs are going to work your students up to understanding. So by the time they're done with this, they've seen all of those. Right? So we're able to do all that. And then we started off and off it'll run, right? And it goes off to my ice filling station. And then on our animation screen here, you can actually see all that moving. Excuse me. And then it goes back. So again, this is all stuff that can be done all on this singular product. Okay. All right. That's all I have for that. Just like I said, there's a lot going on here, a lot of positives, and some great ways to bring this in your classroom. So again, I would open up the floor to any questions. If anybody wants to come up here and try to wire a couple of things, you're more than welcome to do so. Try it out, see what's going on. I encourage you to come on up. Or not. Yes?
So does the equipment, does it teach kids the basic skills in these various areas?
Right. Yes. Yeah. Introductory level. Yep. Yep. Now, that's where our curriculum is right now, right? Okay. But you could use the same exact things and then move it up to that next level. Yes. Yep. Great question. Yes. So the LMS is included with the cost of the equipment. Forever. Yep. And then we'll work with your school or your organization to bring that on board. Yeah, and that's all stuff we'll have to figure out later. You'll work through Tech Labs to do that. That'll all run through your reseller. Yep. All right, well, if there's no other questions, I'll be sticking around till 2 o'clock. You guys are more than welcome to come up and ask questions, and then I got to check a flight right away. So feel free to ask questions up until then. But thank you guys for hearing about our product. Thank you.
So
they're welcome to come up and see.
I'll ask that too. Yeah, folks, if you guys want to come up, ask questions, maybe do a little hands-on. I'm not sure how in-depth we'll get, but Anthony will be here to do that. And then at 2 o'clock, we'll have in this room, the demo room, Matrix, Alistair from Matrix will be presenting, and then the Ignite program from Angelo will be in our
When you were talking about the custom logics and that kind of thing,
Mhm.
versus Allen Bradley or Siemens,
Mhm.
you can't build panels with Allen Bradley or Siemens, right?
It is all Allen Bradley.
It's all Allen Bradley.
Yeah.
He's interested in utilizing Allen Bradley
Mhm.
into it. Okay.
Yeah, yeah. And the reason why we do that is because Fanuc and Allen Bradley are really closely tied together. So with us being a robot integrator, we decided we're going to stick with Allen Bradley. So all, not just the PLC, every component on here.
Oh, it's Allen Bradley.
Yes.
Okay.
Yep. On the pneumatics, all of our stuff is SMC.
Okay. All
Yep.
right.
I can't say all, right? There's always been something,
Yeah.
but generally our first go-to is going to be Allen Bradley.
Okay.
Yep.
I think they use AB and Siemens.
Yeah.
But that was what I wanted to clarify.
Yeah, yeah, and I know Siemens is big down here in the south. That's what I picked up on, but yeah. And we're in the north, so of course we're. Yay!
Collins one area.
Nice to meet you, Collins.
Yeah, I'm an instructor at the Houston Community College.
Okay.